Welcome to Milky Narratives. Beyond the noise of everyday life lies a universe of endless wonder. Tonight we leave Earth behind and journey into the depths of space, where ancient stars, distant worlds, and cosmic mysteries await. Let's begin. What if the largest part of the universe is not made of stars, but of an almost perfect silence we barely understand? Imagine standing on the shore of an endless ocean. The waves are gone, the wind has stopped. Even the sound of your own breathing seems to disappear. Now imagine that this ocean is not made of water, but of space itself. For centuries, humanity has looked upward and believed that the universe is a place filled with dazzling galaxies, blazing stars, colorful nebulae, and unimaginable cosmic explosions. Every breathtaking image captured by our telescopes reinforces the same idea. The cosmos is overflowing with light. But what if those brilliant islands of light are only tiny exceptions? What if almost everything that exists lies between them? A place so vast, so empty, that every galaxy you've ever seen would seem insignificant inside it. Scientists estimate that galaxies occupy only a microscopic fraction of the observable universe. Between these magnificent cities of stars stretches something far stranger than darkness alone, a nearly perfect cosmic emptiness that spans hundreds of millions of light years. This isn't the darkness you experience when you turn off a lamp. It isn't even the darkness between planets. It is a silence so complete that human intuition struggles to comprehend it. No sunlight, no planets, almost no atoms, no familiar landmarks, just an abyss extending farther than the imagination comfortably allows. If you could somehow travel into one of these immense regions, something unsettling would happen. You wouldn't simply feel isolated, you would lose every sense of orientation. There would be no nearby stars to define direction, no glowing nebulae to break the endless black, no neighboring galaxies illuminating the horizon. Even up and down would lose their meaning. The universe would become an infinite ocean without a single visible shoreline. But here's the truly astonishing part. These silent regions are not rare. They are everywhere. In fact, they make up the overwhelming majority of cosmic space. Our universe resembles not a crowded city, but an immense archipelago. Tiny islands of galaxies float inside an ocean so enormous that the islands themselves almost disappear. And yet, despite containing almost nothing, these empty regions may hold some of the greatest secrets in modern cosmology. Why do they exist? How did they become so incredibly vast? Could something invisible be hiding inside them? Or is emptiness itself far more mysterious than we ever imagined? The more astronomers map the large-scale structure of the universe, the stranger the picture becomes. Galaxies are not scattered randomly. Instead, they form enormous filaments stretching across unimaginable distances, weaving together like glowing strands of an immense cosmic web. Clusters connect to superclusters. Filaments intersect across billions of light years. But between these luminous threads lie gigantic bubbles of almost complete emptiness. These are known as cosmic voids. Some of them are so immense that thousands of Milky Ways placed side by side would still fail to cross them. Pause for a moment and try to visualize that. Our own galaxy contains hundreds of billions of stars. It stretches roughly 100,000 light years across. Light itself, the fastest thing in existence, needs 100,000 years to travel from one side to the other. Now multiply that scale, again and again, until even millions of galaxies become tiny measuring sticks. Only then do you begin approaching the dimensions of these silent cosmic oceans. It sounds impossible, almost fictional, yet this is the universe revealed by modern astronomy. Ironically, these empty regions are among the most difficult places to study. Because there is almost nothing inside them, there is almost nothing to observe. Astronomers cannot simply point a telescope into the darkness and expect dramatic images. Instead, they must reconstruct these invisible realms indirectly, tracing the locations of millions of galaxies to reveal the vast blank spaces hidden between them. It's like discovering the shape of invisible continents by mapping only the coastlines. And every new survey reveals something even more astonishing. The universe appears less like scattered islands and more like an unimaginably intricate network suspended over an endless abyss. But perhaps the greatest mystery is psychological. Human beings evolved beneath crowded skies. We instinctively search for patterns, landmarks, familiar points of reference. We feel comforted by structure. The cosmic void offers none. It challenges not only our understanding of astronomy, but our understanding of existence itself. Because if most of reality is almost perfectly empty, what does that say about our place within it? Are galaxies the true substance of the universe, or merely fleeting decorations floating upon a much larger and stranger reality? Every civilization throughout history has gazed toward the stars and imagined that they represented the heart of creation. Yet modern science quietly suggests something profoundly different. Perhaps the stars are only the exceptions. Perhaps silence, not light, is the universe's natural state. And perhaps everything humanity has ever known, our sun, our Earth, our entire galaxy, exists as little more than a tiny spark drifting across an ocean whose true nature we have only begun to glimpse. Because once we leave the familiar neighborhoods of stars behind, the universe transforms into something almost impossible to describe. An endless expanse where distance loses meaning, where darkness becomes a physical landscape, where silence stretches farther than time itself seems capable of measuring. And somewhere within that overwhelming emptiness may lie answers to questions humanity has not yet learned how to ask. Before we venture into these colossal cosmic oceans, we must first understand how the universe built this astonishing web of light and silence, and why emptiness itself may be one of the greatest discoveries in all of science. 2. Why empty space may not be empty. The greatest mystery in the universe may exist in places where nothing appears to exist at all. For a long time, humanity believed that empty space was exactly what its name suggested. Nothing, a perfect absence, a stage upon which stars, planets, and galaxies performed the grand drama of the cosmos. If you removed every atom, every grain of dust, every beam of light, then surely nothing would remain. It seems like common sense. After all, when we think of emptiness, we imagine a box with everything taken out. An empty room, an abandoned road, a silent night. But the universe has an extraordinary habit of turning common sense upside down. As physicists began exploring the smallest scales of reality, they discovered something profoundly unsettling. Space itself refuses to stay empty. Even in regions where no stars shine, where no planets drift, where not a single atom can be found, something is still happening. Imagine zooming in to what appears to be perfect nothingness. Closer, closer still, beyond molecules, beyond atoms, beyond the particles that make up atoms. You might expect to find absolute silence. Instead, you encounter motion, invisible fluctuations, tiny bursts of energy that flicker into existence for unimaginably brief moments before vanishing again. According to quantum physics, what we call a vacuum is anything but lifeless. It behaves more like a restless sea than an empty container. Invisible waves ripple constantly beneath the surface of reality. Particles appear, disappear, reappear. Not because something pushes them into existence, but because the very fabric of space permits these fleeting events to occur. It is one of the strangest predictions ever made by science, and remarkably, many of these predictions have been confirmed through experiments. The emptiness between galaxies may seem motionless from afar, yet at microscopic scales, it could be alive with activity beyond anything our senses could ever perceive. This realization forces us to rethink one of the oldest assumptions in human history. Perhaps emptiness is not the opposite of existence. Perhaps emptiness is another form of existence entirely. Think about the ocean. From an airplane, it can appear perfectly calm, a smooth blue surface stretching toward the horizon. But dive beneath the waves, and an entirely different world emerges. Currents twist through the water, microscopic organisms drift in unimaginable numbers, chemical reactions unfold every second. Life thrives where the surface suggested only stillness. Space may be remarkably similar. From the perspective of galaxies, it appears silent. From the perspective of quantum reality, it may be endlessly dynamic. Yet this mystery extends far beyond tiny particles. Astronomers have uncovered another puzzle hiding inside the darkness. When they observe distant galaxies, they notice something unexpected. Light traveling across billions of years does not always behave exactly as predicted. The expansion of the universe itself appears to be accelerating. Instead of slowing down under gravity, everything is moving apart faster and faster. Galaxies race away from one another. The cosmic web stretches wider. The silent voids grow larger over time. Something seems to be pushing the universe outward. But what? No one has ever directly seen the force responsible. Scientists call it dark energy, not because they know what it is, but because they know almost nothing about it. The name itself is an admission of mystery. Whatever dark energy may be, it appears to dominate the cosmos. Ordinary matter, the stars, planets, gas clouds, and every living creature that has ever existed, accounts for only a tiny fraction of the universe's total energy budget. The overwhelming majority belongs to invisible components we cannot see. Dark matter, dark energy. Together they shape the evolution of the cosmos while remaining almost completely hidden. This creates a remarkable possibility. When we stare into the vast emptiness between galaxies, we may actually be looking directly at the regions where dark energy reveals its influence most clearly. The voids are not simply gaps. They are laboratories. Natural experiments spanning hundreds of millions of light years. Because there is so little ordinary matter inside them, the subtle effects of the universe itself become easier to detect. It's almost like listening for a whisper. In a crowded city, the noise overwhelms everything. But in a silent desert, even the faintest sound becomes noticeable. Cosmic voids provide that silence. By removing most of the visible matter, they allow astronomers to study the invisible architecture holding the universe together. And the more carefully researchers examine these immense regions, the more surprising they become. Some voids appear larger than theoretical models once predicted. Others possess shapes that hint at ancient gravitational interactions, stretching back nearly to the birth of the universe. Even the distribution of galaxies around their edges tells a story written billions of years ago. In a strange way, emptiness preserves history. While galaxies constantly evolve through collisions, star formation, and violent explosions, the great voids change much more slowly. They act like enormous cosmic fossils, preserving clues about conditions that existed shortly after the Big Bang. It is astonishing to think that by studying what seems to contain almost nothing, scientists may uncover answers about everything. The origin of cosmic structure, the nature of gravity, the fate of the expanding universe, perhaps even entirely new laws of physics waiting beyond our current understanding. History offers a fascinating lesson. Again and again, humanity has mistaken ignorance for emptiness. We once believed the sky contained only a few thousand stars. Then telescopes revealed billions. We once thought atoms were indivisible. Then we discovered worlds hidden inside them. We once assumed the Milky Way was the entire universe. Now we know it is only one galaxy among hundreds of billions. Each time we declared, "There is nothing there," nature quietly replied, "Look closer." Perhaps we stand at that same threshold once again. The immense silence between galaxies may not represent the absence of reality. Instead, it could be the deepest layer of reality we have ever encountered. A place where the universe whispers instead of shouts, where invisible forces sculpt the cosmos on scales beyond imagination, and where the greatest discoveries of the coming century may emerge, not from brilliant stars blazing across the heavens, but from the profound, almost perfect darkness stretching silently between them. 3. Could reality be constantly rewriting itself? Every second, the universe may be changing in ways so subtle that no human being has ever noticed. It is a strange thought. Not that stars are born and galaxies collide. We already know those grand cosmic events unfold across millions or even billions of years. Those changes are dramatic, visible, and expected on the vast stage of astronomy. The stranger possibility is something much quieter. What if reality itself is never completely still? What if the universe is constantly adjusting, correcting, reshaping itself in tiny ways so delicate that no instrument has yet detected them directly? Imagine watching the surface of a perfectly calm lake. At first glance, it appears motionless. The reflection of the sky seems frozen. Trees stand mirrored with flawless precision. But look closer. Invisible currents move beneath the surface. Minute ripples travel from distant shores. Tiny insects disturb the water for only an instant before disappearing again. The lake was never truly still. Perhaps reality is something similar. To human perception, the universe appears stable. Physical laws seem fixed. Gravity behaves the same today as yesterday. Light travels at the same incredible speed. Atoms follow familiar patterns that allow chemistry, biology, and life itself to exist. This remarkable consistency gives us confidence that the universe is governed by permanent rules. Yet modern physics leaves open fascinating possibilities. Some theories suggest that what we call constants may not be perfectly constant after all. Take the fine structure constant, for example, a number that determines the strength of electromagnetic interactions. It shapes how atoms hold together. It influences the colors of stars. It quietly governs much of the chemistry that makes planets, oceans, and living cells possible. Scientists have carefully measured this constant for decades. So far, it appears astonishingly stable. But researchers continue searching for even the slightest hint that it might vary across immense distances or unimaginably long periods of cosmic history. Not because they expect dramatic changes tomorrow, but because discovering even the tiniest variation would transform our understanding of reality. It would suggest that the universe is not a finished structure carved in stone. Instead, it might resemble a living process, a cosmos still evolving at its deepest level. Other ideas go even further. Some physicists wonder whether the vacuum itself, the seemingly empty fabric of space, is not entirely stable. Quantum field theory describes space as existing in different possible energy states. The one we currently inhabit may simply be the lowest state accessible, or perhaps only a temporary one. This leads to one of the most intriguing concepts in theoretical physics: false vacuum decay. Imagine balancing a marble inside a shallow valley. It appears stable. A gentle push changes nothing. But somewhere beyond the nearby hills lies an even deeper valley. If the marble somehow reached that lower position, its entire environment would change. Now replace the marble with the vacuum of space itself. If a transition to a lower energy state were ever possible, it could spread outward at the speed of light, fundamentally altering the laws of physics inside its expanding boundary. Atoms might no longer exist in their familiar forms. Stars could not shine the way they do now. Chemistry itself might become impossible. Fortunately, there is no evidence that such a transition is occurring. If it is possible at all, it may never happen during the entire lifetime of the universe. Still, the idea reminds us of something profound. The reality we experience may be more delicate than it appears. Even permanence could be temporary on cosmic timescales. Yet rewriting reality does not necessarily require catastrophic events. The universe already rewrites itself through countless subtle processes. Every star slowly changes as nuclear fusion transforms hydrogen into helium. Every galaxy evolves as gravity rearranges billions of stars. Every black hole quietly grows by gathering surrounding matter. Even empty space expands continuously. This cosmic expansion is so gentle that we never notice it within our daily lives. The distance between galaxies increases by tiny amounts every second. Over millions of years, those tiny changes become enormous. Galaxies that once interacted drift beyond one another's reach. Future civilizations, if any exist trillions of years from now, may look into the sky and see a universe very different from ours. Most galaxies will have disappeared beyond the observable horizon. They may never know the rich cosmic landscape we enjoy today. Their understanding of reality would naturally differ from ours, not because nature changed suddenly, but because gradual evolution quietly reshaped what could be observed. Time itself may also be part of this ongoing rewriting. Some approaches to quantum gravity suggest that space-time may not be perfectly continuous. Instead of flowing smoothly like water, reality at unimaginably tiny scales might resemble a woven fabric composed of discrete pieces. If so, what appears continuous could actually emerge from countless microscopic events, constantly updating the structure of existence. Like individual frames in a film creating the illusion of uninterrupted motion. Our eyes never notice the separate images. We simply experience the story. Perhaps the universe tells its story in much the same way, frame by frame, moment by moment. Reality appearing seamless because every transition is extraordinarily small. Even information may participate in this hidden evolution. Modern physics increasingly views information as a fundamental ingredient of nature. Black hole research, quantum computing, and holographic theories all point toward a universe where information is not merely something stored inside reality. It may actually help define reality itself. If information is constantly flowing, transforming, and reorganizing, then perhaps the universe is continuously editing its own description. Not rewriting history, not erasing the past, but updating the present with every interaction between particles, every emitted photon, every gravitational wave traveling silently across intergalactic space. It becomes less like a finished painting and more like an endless symphony. Each note follows naturally from those before it, yet every new note subtly changes the meaning of the entire composition. This perspective carries an unexpected sense of peace. We often seek permanence. We want certainty. We hope the world beneath our feet is completely fixed. But perhaps beauty lies precisely in its gentle evolution. The mountains on Earth are slowly reshaped by wind. Forests renew themselves through seasons. Rivers carve valleys grain by grain. None of these transformations feel alarming. They are simply part of nature's rhythm. Maybe the universe follows a similar rhythm on scales almost impossible to imagine. A patient unfolding, a quiet refinement, a reality that is never frozen, yet never chaotic. Instead, balanced delicately between order and possibility. This idea also changes how we see ourselves. Every atom in your body has traveled through ancient stars. Every breath exchanges molecules with the atmosphere. Your thoughts emerge from electrical patterns lasting only fractions of a second before becoming something new. You are already an example of constant change, not despite your identity, but because of it. The universe does not preserve itself by remaining perfectly still. It preserves itself through continuous transformation. Perhaps reality itself works the same way. A masterpiece that is never entirely complete. A story whose next sentence is always being written. And although we may never witness the deepest revisions taking place beneath existence, we are nevertheless participants within them. Every observation, every discovery, every question asked beneath the night sky becomes another small chapter in humanity's attempt to understand the extraordinary universe we inhabit. Perhaps the greatest mystery is not whether reality changes. It almost certainly does. The greater mystery is whether we have only begun to notice how quietly those changes have always been unfolding. If these quiet journeys through the universe help you relax while discovering new wonders, consider subscribing and joining us for more peaceful explorations beneath the stars. 4. The hidden geometry that shapes everything. When we look into the night sky, everything appears scattered, almost randomly. Stars sparkle in every direction. Galaxies drift across unimaginable distances. Nebulae bloom like clouds of colored smoke. At first glance, the universe seems beautifully chaotic, as though gravity simply gathered matter wherever chance allowed. But what if that impression is only an illusion? What if, hidden beneath the apparent disorder, there exists a breathtaking architecture so vast that no telescope can fully reveal it? Imagine dropping thousands of tiny leaves onto the surface of a still pond. To an observer standing far away, they might appear to have landed randomly. Yet if the water carries invisible currents beneath the surface, every leaf slowly drifts into elegant patterns, shaped by forces that cannot be seen. The universe may behave in much the same way. For decades, astronomers believed galaxies were sprinkled throughout space somewhat unevenly, but without any larger design. As telescopes improved and surveys expanded to map millions of galaxies, something astonishing emerged. Instead of isolated islands floating alone, galaxies seemed connected. Clusters linked together, filaments stretched across unimaginable distances. Great walls of galaxies extended hundreds of millions of light years. Between these luminous threads lay enormous cosmic voids, regions containing almost no galaxies at all. The universe began to resemble something strangely familiar. Not a random scattering, not a collection of disconnected objects, but a vast cosmic web. Seen from enough distance, this web bears an uncanny resemblance to neural networks inside the human brain, the branching veins of leaves, with a delicate strand spun by spiders before dawn. Of course, these similarities do not imply that the universe is literally alive or conscious. Rather, they reveal that nature often organizes complexity using surprisingly similar mathematical principles, regardless of scale. Tiny systems and enormous ones sometimes obey the same elegant rules. This realization has transformed how scientists think about cosmic evolution. Galaxies may not simply form wherever matter happens to gather. Instead, they emerge along invisible pathways established billions of years earlier. Long before the first stars ignited, tiny fluctuations in the density of matter filled the infant universe. These differences were astonishingly small. Some regions were only slightly denser than others, variations smaller than 1 part in 100,000. Yet gravity is remarkably patient. Over billions of years, those tiny differences slowly grew. Dense regions attracted more matter. More matter strengthened gravity. Gravity attracted even more matter. Without any urgency, without any guiding hand, enormous structures gradually emerged from almost imperceptible beginnings. It is one of nature's quietest miracles. From nearly perfect uniformity came extraordinary complexity. The patterns astronomers observe today were not suddenly created. They were gently amplified by time itself. Dark matter appears to play a central role in this hidden architecture. Although invisible, it outweighs ordinary matter by roughly 5 to 1. Scientists cannot observe it directly because it neither emits nor reflects light, yet its gravitational influence is unmistakable. Many researchers describe dark matter as the invisible scaffolding upon which galaxies assemble. Imagine constructing a magnificent cathedral. Before the walls, windows, and towers are completed, workers first erect an unseen framework that supports every stone. Eventually, the temporary structure disappears from view, but without it, the cathedral could never have taken shape. Dark matter may have provided a similar framework for the visible universe. Ordinary matter, the atoms that become stars, planets, oceans, and living creatures, simply followed the gravitational landscape already prepared. In this way, much of the universe's beauty may have been quietly determined by something we still cannot identify. Even more fascinating is the role mathematics plays in describing these structures. Across nature, certain geometric forms appear again and again. Branching trees maximize exposure to sunlight. River systems efficiently drain continents. Blood vessels distribute oxygen throughout living bodies. Lightning spreads through the atmosphere, following intricate branching paths. The cosmic web exhibits surprisingly similar characteristics. These repeating patterns emerge because simple physical rules often produce extraordinarily complex outcomes. No architect sits outside the universe drawing blueprints. Instead, geometry unfolds naturally through the interaction of gravity, motion, and time. Some researchers refer to this as emergence, the spontaneous appearance of order arising from simple laws followed consistently over immense timescales. The concept is both humbling and beautiful. It suggests that elegance does not always require intention. Sometimes order simply blossoms from persistence. As simulations become more sophisticated, computers can recreate much of the universe's large-scale structure using only a handful of fundamental physical laws. Starting with tiny fluctuations shortly after the Big Bang, these models gradually produce networks strikingly similar to the cosmic web astronomers observe today. This agreement between theory and observation provides one of modern cosmology's greatest successes. Yet many mysteries remain. No simulation captures every detail perfectly. Some galaxies appear earlier than expected. Others behave differently than current models predict. The hidden geometry is becoming clearer, but the complete picture remains unfinished. Perhaps this is what makes the universe so endlessly captivating. Every answer reveals another layer waiting beneath it. Every map exposes an even larger landscape. Every solved equation uncovers deeper questions. And perhaps geometry itself extends beyond what we currently imagine. Some physicists wonder whether space is fundamentally smooth or composed of unimaginably tiny building blocks. Others investigate whether additional dimensions, curled beyond ordinary perception, subtly influence the shape of reality. These ideas remain speculative, but they remind us that our understanding of space is still evolving. Centuries ago, humanity believed Earth stood at the center of everything. Later, we discovered we orbit an ordinary star. Then we learned our galaxy is merely one among hundreds of billions. Now we are beginning to realize that even galaxies themselves may simply be luminous intersections within an invisible cosmic framework stretching farther than our minds can comfortably imagine. Perhaps the greatest lesson hidden inside this geometry is not about mathematics alone. It is about perspective. From our small place on Earth, individual events often feel isolated. A single sunrise, a single storm, a single human lifetime. Yet from enough distance, everything belongs to larger patterns unfolding across scales we rarely notice. The atoms inside our bodies were forged within ancient stars. Those stars formed inside galaxies. Those galaxies gathered along invisible filaments shaped by gravity over billions of years. In an unexpected way, every person carries within them a history written by the geometry of the cosmos. Not because the universe planned our existence, but because every chapter naturally followed the one before it. Perhaps the hidden architecture of the universe is not a rigid blueprint dictating every outcome. Instead, it may be more like the gentle contours of a landscape. A river follows the valleys carved before it, yet every drop of water traces its own unique path. Likewise, galaxies, stars, planets, and eventually life itself may arise within possibilities quietly shaped by invisible patterns stretching across the cosmos. And somewhere beyond the farthest galaxies we can currently observe, those patterns continue, silent, patient, expanding, drawing structures so immense that even the oldest light in the universe has not yet had enough time to reveal them completely. The deeper we explore, the more the universe seems less like scattered chaos and more like a masterpiece woven from invisible threads. Threads whose full design we are only just beginning to glimpse. 5. Before the first light ever appeared. Long before the first star illuminated the darkness, the universe had already begun telling a story we can only partially reconstruct. When we imagine the beginning of the universe, our minds often leap immediately to brilliant explosions of light. We picture blazing stars igniting one after another. We imagine galaxies swirling into existence. We envision the cosmos suddenly bursting with color and motion. But the universe did not awaken in light. For a surprisingly long time, it remained wrapped in darkness. Not the comforting darkness of a quiet night beneath familiar constellations. Not the darkness between distant stars. This was a darkness unlike anything we have ever experienced. A universe without a single sun, without a single planet, without a single source of visible light. Yet even within that immense blackness, the story of everything had already begun. The foundations of every galaxy, every star, every atom in your body were quietly taking shape long before the cosmos became visible. It is one of astronomy's greatest achievements that we can reconstruct parts of this invisible era. Not because anyone witnessed it. No observer existed. No telescope could have watched those earliest ages unfold. Instead, scientists read the universe much as archaeologists read ancient civilizations. Tiny clues remain scattered throughout space, subtle patterns preserved in radiation, the distribution of galaxies, the chemistry of ancient stars. Together, these clues allow us to piece together fragments of a history written nearly 14 billion years ago. Immediately after the Big Bang, the universe was unimaginably hot. Matter and energy existed in a dense, turbulent state, unlike anything seen today. Temperatures were so extreme that ordinary atoms could not survive. Electrons moved freely through a glowing sea of charged particles. Light itself struggled to travel. Photons constantly collided with electrons, scattering in every direction. The universe, paradoxically, was filled with brilliant radiation while remaining effectively opaque. There was light everywhere, yet nothing could truly be seen. Only after roughly 380,000 years did conditions finally cool enough for electrons to combine with atomic nuclei. Hydrogen and helium, the simplest elements, formed in enormous quantities. For the first time, light could move freely across space. That ancient light continues traveling today. Stretched by billions of years of cosmic expansion, it now reaches us not as visible light, but as faint microwave radiation, known as the cosmic microwave background. It is often described as the oldest photograph ever taken, not because it captures stars or galaxies. There were none. Instead, it records the universe itself as an infant, astonishingly smooth yet carrying tiny fluctuations that would later grow into everything we know. Then, something remarkable happened. After the release of this ancient light, the universe entered a period that astronomers poetically call the Cosmic Dark Ages. Despite the dramatic name, this era was not empty. Hydrogen filled nearly all of space. Dark matter continued shaping invisible gravitational landscapes. The universe expanded steadily. Time flowed onward. Yet no stars had formed. There were no glowing galaxies, no brilliant nebulae. If an impossible observer could have floated through space during this age, the cosmos might have appeared almost perfectly black. Only the faint afterglow of the Big Bang would have existed, invisible to human eyes. It was a universe waiting patiently. Gravity, however, never sleeps. Across millions of years, tiny differences in density slowly grew larger. Regions containing slightly more matter pulled in additional gas. Those clouds became heavier, pressure increased, temperatures rose. Eventually, gravity won its quiet battle against expansion inside these dense pockets. The first stars were born. These earliest stars were unlike those scattered across today's night sky. Because the universe contained almost nothing except hydrogen and helium, they grew to extraordinary sizes. Many may have been hundreds of times more massive than our sun. Their immense weight compressed their cores until nuclear fusion ignited with incredible intensity. For the first time since the universe became transparent, brilliant starlight pierced the darkness. One by one, isolated beacons appeared across the expanding cosmos. The cosmic dark ages gradually came to an end. Yet these first stars lived fast and died young. Massive stars burned through their nuclear fuel astonishingly quickly. Many survived only a few million years, a brief moment compared to the sun's expected lifetime of 10 billion years. When they exhausted their fuel, they exploded as colossal supernovae. These explosions were not merely spectacular endings, they were acts of creation. Inside their blazing interiors, new elements had been forged. Carbon, oxygen, silicon, iron, elements that had never previously existed. The atoms required for rocky planets, oceans, mountains, and eventually living organisms were manufactured inside these first stellar generations. In a profound sense, the universe spent hundreds of millions of years preparing the ingredients necessary for life before life itself ever became possible. Every breath you take contains oxygen forged inside ancient stars, the calcium in your bones, the iron in your blood, the carbon forming every cell of your body. Each atom carries a history stretching back through countless generations of stellar birth and death. The universe literally learned to build complexity through repetition. Stars created elements, explosions scattered them, new stars formed from enriched clouds, planets emerged around younger suns. Over unimaginable spans of time, simple beginnings gradually produced astonishing diversity. This slow accumulation of complexity remains one of nature's most elegant processes. Nothing appeared fully formed. Everything emerged step by patient step. Modern observatories are now beginning to glimpse these ancient epochs directly. Powerful space telescopes peer so deeply into space that they effectively look backward through time. Because light travels at a finite speed, observing distant galaxies allows astronomers to witness the universe as it existed billions of years ago. Each increasingly distant galaxy reveals another chapter closer to the beginning. Every observation slightly sharpens our understanding of how darkness transformed into light. Yet mysteries remain abundant. Exactly when did the first stars ignite? How rapidly did they reshape the surrounding hydrogen? What kinds of galaxies appeared first? How did enormous black holes form so surprisingly early? Every discovery answers one question, while opening several more. The earliest chapters of cosmic history remain incomplete. Perhaps they always will. There is a quiet beauty in that uncertainty. Some stories are more meaningful because they are only partially known. Like fragments of an ancient manuscript discovered beneath desert sands, the missing pages invite imagination while encouraging deeper exploration. Science does not diminish wonder by replacing mystery with certainty. Instead, it transforms mystery into a journey. Every new observation becomes another carefully translated sentence from the universe's oldest language. As we continue reconstructing those forgotten ages, we realize something extraordinary. The darkness before the first stars was not empty time waiting for the real story to begin. It was the story. It was the patient opening chapter in which gravity assembled the stage, matter gathered into invisible structures, and the conditions for future brilliance quietly emerged. Without those silent hundreds of millions of years, no galaxies would ever have formed. No planets would have circled distant suns. No oceans would have reflected starlight. No living creatures would have looked upward and wondered where they came from. Sometimes beginnings are almost invisible. Seeds grow beneath the soil before any green leaf reaches sunlight. Children learn countless unseen skills before speaking their first words. The universe itself spent vast ages preparing for its first visible masterpiece. Perhaps that is one of its gentlest lessons. The most important transformations often begin long before anyone notices them. Before the first light appeared, the universe was already becoming everything it would one day be. And in that immense, silent darkness, the future of every star, including our own sun, was already quietly unfolding. 6. The strange future waiting for every star. Even the brightest suns eventually surrender to time, but their endings may be stranger than their beginnings. When we look into the night sky, it is easy to imagine the stars as eternal. They seem fixed, dependable, glowing with the same quiet brilliance that guided ancient travelers thousands of years ago. Yet every point of light above us is living through its own story, a story measured not in days or centuries, but in millions and billions of years. Nothing in the universe shines forever. Every star, no matter how massive or humble, is slowly spending the fuel that allows it to exist. The sunlight warming Earth this very moment is powered by nuclear fusion deep within the sun's core, where hydrogen atoms merge into helium under unimaginable pressure. This process has continued for roughly 4.6 billion years, creating enough energy to illuminate an entire solar system. But even a star as steady as our sun possesses only a finite supply. Although its end remains billions of years away, the clock has been ticking since the moment it first ignited. There is something strangely comforting about this realization. The stars are not permanent monuments standing outside time. They are travelers moving through time alongside us, simply on a scale so vast that their changes become almost invisible within a human lifetime. Imagine watching a flower bloom over several weeks. Now imagine trying to observe the same process if it unfolded over 10 billion years. To us, the flower would appear perfectly unchanged. This is essentially how we observe stars. Even with powerful telescopes, astronomers rarely witness dramatic changes in individual stars because stellar evolution unfolds so slowly. Instead, scientists reconstruct these cosmic life cycles by observing millions of stars at different stages, almost like assembling a family album whose photographs were scattered across the universe. Some stars are only beginning to shine. Others have reached peaceful middle age. Some are quietly approaching their final chapters. Together, they reveal one of the most elegant stories nature has ever written. For stars similar to our sun, the ending begins almost imperceptibly. As hydrogen becomes scarce inside the core, gravity slowly gains the upper hand. The core contracts, temperatures rise, and fusion begins in surrounding layers instead. The outer atmosphere responds by expanding outward. The star becomes a red giant. Its surface cools slightly, giving it a reddish glow, but its total size increases enormously. If our own sun eventually reaches this phase, it may swell beyond the current orbit of Mercury and perhaps even Venus. Earth's ultimate fate remains an active area of research, but regardless of the exact outcome, our planet will no longer resemble the blue world we know today. The oceans will have vanished long before then. The atmosphere will have been stripped away. The continents themselves may melt beneath relentless heat. Yet this transformation is not an act of destruction alone. it is also an act of creation. Inside red giants, new elements begin to form: carbon, oxygen, and other building blocks that did not exist when the star was first born. Every breath we take depends upon atoms that were once forged inside ancient stars like these. The carbon in your cells, the calcium in your bones, the oxygen filling your lungs. All were manufactured inside stellar furnaces billions of years before Earth even existed. When astronomer Carl Sagan famously remarked that we are made of star stuff, he was not speaking metaphorically. He was describing literal history. Eventually, stars like the Sun gently shed their outer layers into space, creating beautiful glowing clouds known as planetary nebulae. Despite the name, these objects have nothing to do with planets. Early astronomers simply thought they resembled tiny planetary disks through primitive telescopes. At the center remains a white dwarf. This tiny stellar ember packs roughly the Sun's mass into a sphere about the size of Earth. A teaspoon of its material would weigh several tons under Earth's gravity. Yet despite its incredible density, the white dwarf no longer generates new energy through fusion. It simply radiates away the immense heat accumulated during its lifetime. For trillions upon trillions of years, it slowly cools, its light gradually fades. Eventually, in an unimaginably distant future, it may become what astronomers call a black dwarf, a cold, dark remnant drifting silently through space. Interestingly, the universe itself is not yet old enough for any black dwarfs to exist. Every white dwarf ever created is still cooling. Some endings, it seems, require even more patience than beginnings. But not every star departs so peacefully. Massive stars follow a dramatically different path. These cosmic giants burn their fuel with astonishing speed. Although they contain vastly more hydrogen than smaller stars, they consume it at such extraordinary rates that many survive only a few million years, a brief lifetime by cosmic standards. They live fast, they die spectacularly. As heavier and heavier elements accumulate inside their cores, fusion becomes increasingly difficult until iron eventually forms. Unlike lighter elements, iron cannot release energy through further fusion. The balance between gravity and outward pressure suddenly collapses. Within seconds, the star's core implodes. Then comes one of the most violent events in the known universe, a supernova. For a brief period, a single exploding star may outshine an entire galaxy containing hundreds of billions of other stars. Shockwaves race across surrounding space, carrying newly created elements into nearby clouds of gas and dust. These enriched clouds later become the raw material for entirely new generations of stars and planets. In a profound sense, every supernova plants seeds for future worlds. Without them, rocky planets like Earth might never have formed. Life itself could have remained impossible. The universe recycles its own history with astonishing efficiency. Even stranger are the remnants left behind. If the original star possessed enough mass, gravity crushes the remaining core into a neutron star, a city-sized object containing more mass than our Sun. A single teaspoon would outweigh mountains. Inside, matter exists in forms that laboratories on Earth cannot reproduce. Some neutron stars spin hundreds of times every second, sweeping powerful beams of radiation across the galaxy like gigantic celestial lighthouses. Others collide with one another after millions of years of slow orbital dance, generating gravitational waves that ripple through space-time itself. And if the original star was even larger, gravity may refuse to stop. No known force can halt the collapse. The star disappears behind an event horizon, leaving behind one of nature's deepest mysteries, a black hole. Ironically, what begins as one of the brightest stars in the galaxy may ultimately become the darkest object imaginable. Light enters, nothing returns. Yet even black holes may not last forever. According to theoretical work combining quantum mechanics and gravity, black holes could slowly evaporate through an astonishingly subtle process known as Hawking radiation. The larger the black hole, the slower this occurs. For the most massive ones, complete evaporation may require numbers of years so immense that ordinary language struggles to express them. The future of the universe stretches far beyond our intuitive imagination. Stars fade, galaxies drift apart. New stars eventually stop forming as raw gas becomes exhausted. One by one, the great lights of the cosmos quietly disappear. It is a future sometimes called the stelliferous era, giving way to an age of fading embers, a universe growing darker not through catastrophe, but through extraordinary patience. Yet there is an unexpected beauty hidden within this vision. Nothing is wasted. Every ending creates the conditions for something new. The death of one generation of stars becomes the birthplace of another. The atoms forged in forgotten suns become planets, oceans, forests, and eventually curious minds capable of asking where those atoms came from. Perhaps this is the quiet rhythm of the cosmos. Not endless permanence, but endless transformation. And as we continue our peaceful journey through these vast timescales, an even deeper question begins to emerge. If stars themselves are temporary, then what does the ultimate future of the entire universe look like when even the last light has finally gone out? 7. When gravity becomes the architect of reality. Gravity may be doing far more than pulling objects together. It could be quietly shaping reality itself. After following the lives of stars from their brilliant births to their quiet or explosive endings, a deeper question begins to emerge. What force has been patiently guiding every chapter of this cosmic story? Stars are born because immense clouds of gas collapse. Galaxies gather into graceful spirals. Planets settle into stable orbits. Black holes grow in the hearts of ancient galaxies. Again and again, one invisible influence appears behind every transformation: gravity. Most of us encounter gravity in ordinary ways. It keeps our feet firmly planted on the Earth. It causes rain to fall. It guides the moon around our planet and the Earth around the sun. It feels so familiar that we rarely stop to think about it. Yet among the 4 known fundamental forces of nature, gravity remains the most mysterious. It is astonishingly weak compared with the others. A small refrigerator magnet can easily overcome the gravitational pull of the entire Earth by lifting a simple paperclip. And yet, despite this apparent weakness, gravity alone dominates the architecture of the cosmos. Over enormous distances and unimaginably long stretches of time, its quiet persistence shapes nearly everything we see. For centuries, gravity seemed straightforward. Isaac Newton described it as an invisible attraction between masses. His equations explained falling apples, planetary orbits, and the movements of comets with remarkable precision. The universe appeared almost mechanical, a magnificent clockwork governed by predictable rules. Then, in the early 20th century, a new perspective transformed our understanding forever. Albert Einstein proposed something far stranger. According to his general theory of relativity, gravity is not truly a force pulling objects together. Instead, mass and energy change the very geometry of space and time. Imagine placing a heavy stone onto a stretched sheet of fabric. The surface bends beneath the weight. Now roll a marble nearby. Rather than being pulled directly toward the stone, the marble simply follows the curved surface. This familiar demonstration is only an analogy, yet it hints at a profound reality. Space itself may curve. Time itself may bend. Objects simply follow the natural path within this curved geometry. The Earth does not orbit the Sun because an invisible rope connects them. Instead, our planet travels through the gentle curvature the Sun creates in space-time. Gravity, then, is not merely something acting within the universe. It may actually describe the shape of the universe itself. This realization changes the way we think about reality. Space is no longer an empty stage upon which cosmic events unfold. The stage itself responds to every actor. Every star slightly reshapes space-time. Every galaxy contributes to the overall cosmic landscape. Even you, despite your tiny mass compared to astronomical objects, curve space-time ever so slightly, simply by existing. The effect is unimaginably small, but according to Einstein's equations, it is real. Nothing possessing mass is completely separate from the geometry surrounding it. This intimate relationship between matter and space has produced some of the most astonishing discoveries in modern astronomy. One of them is gravitational lensing. Imagine observing a distant galaxy billions of light years away. Between that galaxy and Earth sits an enormous cluster of galaxies. Its immense gravity bends the surrounding space-time so dramatically that light itself changes direction while passing nearby. To us, the distant galaxy may appear stretched into luminous arcs, or even duplicated several times across the sky. The cluster acts like a gigantic natural lens. Remarkably, gravity can focus light without touching it. Astronomers now use gravitational lensing as one of their most powerful tools. It allows them to detect invisible dark matter, measure the masses of distant galaxy clusters, and observe galaxies so remote that ordinary telescopes alone could never reveal them. Gravity quietly becomes an instrument through which the universe helps us observe itself. Then there are gravitational waves. For decades, Einstein believed these ripples in space-time should exist, but he doubted they would ever be detected. The distortions they produce are unimaginably small. When two massive black holes collide billions of light years away, they send waves traveling across the universe at the speed of light. By the time those waves reach Earth, they alter distances by less than the width of an atomic nucleus over kilometers of space. And yet, in 2015, humanity finally measured them. Specialized observatories detected space-time itself stretching and compressing as these ancient ripples washed silently across our planet. For the first time, we were not simply looking at the universe. We were listening to it. The cosmos had revealed an entirely new language. Instead of light, it spoke through geometry. The more scientists explore gravity, the more profound its role appears to become. Some physicists now wonder whether gravity is even more fundamental than we currently understand. Could space-time itself emerge from deeper quantum processes? Might gravity somehow connect the microscopic world of quantum mechanics with the vast structures described by relativity? This remains one of the greatest unsolved challenges in physics. General relativity beautifully explains planets, stars, galaxies, and black holes. Quantum mechanics describes atoms and subatomic particles with astonishing accuracy. Yet these two extraordinary theories refuse to fit together completely. Somewhere beneath them may lie an even deeper description of reality. One possibility suggests that space-time is not continuous, but composed of unimaginably tiny units. Another imagines that gravity emerges from hidden information encoded throughout the universe. Others investigate whether additional dimensions beyond our familiar 3 dimensions of space subtly influence gravitational behavior. These ideas remain speculative. They have not yet been confirmed, but they reveal how much of reality still waits to be understood. Perhaps gravity is not merely one force among many. Perhaps it is a clue pointing toward an entirely new understanding of existence. There is also something deeply poetic about gravity's patience. Unlike explosive supernovae or brilliant quasars, gravity rarely announces itself dramatically. Its greatest achievements come through persistence. Given enough time, it gathers diffuse clouds into stars. It assembles stars into galaxies. It organizes galaxies into clusters and immense filaments spanning hundreds of millions of light years. It sculpts the universe through quiet determination rather than sudden force. Nature often rewards patience. Gravity may be its greatest example. Even our own existence depends upon this invisible architect. Without gravity, the sun could never have ignited. Without gravity, Earth would never have formed. Without gravity, our atmosphere would drift into space, our oceans would disappear, and life as we know it could never have emerged. The simple act of taking a breath depends upon a chain of gravitational events stretching back nearly 14 billion years. Every heartbeat echoes a story written by collapsing clouds of gas, orbiting planets, and ancient stars, held together by the same quiet influence. Perhaps that is why gravity feels strangely familiar. It is not merely something acting upon us. It is one of the reasons we are here at all. As our journey through the universe continues, we begin to see gravity differently. No longer just the force that causes apples to fall, no longer merely the reason planets remain in orbit. Instead, it becomes something far more profound. A patient sculptor, an invisible architect, a silent artist shaping galaxies, bending light, carrying ripples across space-time, and quietly guiding the evolution of the cosmos itself. The universe may seem vast beyond imagination. Its mysteries may still outnumber its answers. But if one gentle thread connects every chapter of its story, it is gravity. A force so subtle that we hardly notice it in daily life, yet so powerful that it has helped write the history of everything we have ever known. If these peaceful cosmic stories bring you comfort and inspire your curiosity, consider subscribing and joining us for more quiet journeys through the mysteries of the universe. Together we'll continue exploring the silent forces, ancient stars, and hidden wonders that shape the cosmos, one peaceful story at a time. 8. The places where time refuses to behave. There are regions of the cosmos where time itself seems to flow differently, challenging everything we experience every day. After discovering how gravity quietly sculpts galaxies, bends light, and shapes the very fabric of space-time, another remarkable realization begins to emerge. If gravity can bend space, could it also bend time? At first, the idea sounds almost impossible. Time feels constant. Every second seems identical to the one before it. Our clocks tick steadily. The sun rises and sets with comforting regularity. We grow older day by day without ever noticing anything unusual about the flow of time itself. For most of human history, this seemed perfectly obvious. Time was thought to move uniformly everywhere throughout the universe, like an invisible river flowing at exactly the same speed for everyone. But nature, once again, proved to be far stranger than intuition. According to Einstein's general theory of relativity, space and time are not separate things. Together, they form a single woven fabric, known as space-time. When gravity bends space, it also bends time. This means that time itself does not always pass at the same rate. Instead, its flow depends upon where you are and how strong the surrounding gravity happens to be. It is an astonishing conclusion. The universe possesses no universal clock. Every observer carries their own. Imagine two identical clocks. One remains on Earth's surface. The other is carried aboard a spacecraft orbiting high above the planet. After enough time has passed, the two clocks will no longer agree perfectly. The clock closer to Earth gravity will have ticked ever so slightly more slowly. The difference is incredibly small, far too tiny for us to notice in everyday life. But modern atomic clocks measure it with extraordinary precision. In fact, this effect is so real that it must be accounted for every day in the global positioning system. GPS satellites orbit about 20,000 kilometers above Earth. Because they experience weaker gravity than clocks on the ground, their onboard clocks run slightly faster. At the same time, because the satellites move rapidly through space, another relativistic effect causes their clocks to slow slightly. Engineers must carefully correct for both effects. Without these corrections, navigation errors would accumulate by several kilometers every single day. The smartphone in your pocket quietly depends upon Einstein's strange view of time. Relativity is not merely an abstract theory, it is part of modern life. Now imagine leaving Earth's gentle gravity altogether. Suppose you could travel toward one of the universe's most extreme objects, a black hole. Long before crossing its event horizon, you would begin entering a region where gravity becomes unimaginably intense. To you, nothing unusual would happen to your own heartbeat. Your thoughts would feel normal. Your watch would continue ticking exactly as always. Time never seems strange to the person experiencing it. The real difference appears only when someone far away compares their clock with yours. From a distant spacecraft watching safely outside the black hole's influence, your movements would appear to slow. Every gesture would become more gradual. Every second would stretch longer. As you approach the event horizon, you would seem to move almost imperceptibly. Your image would grow dimmer and redder as the light escaping your vicinity lost energy climbing away from the immense gravity. To the distant observer, it would appear almost as though time itself were freezing. Meanwhile, from your own perspective, the outside universe would appear to speed up. Millions of years could seem to unfold while only a short period passed for you. This extraordinary effect is known as gravitational time dilation. It has been confirmed repeatedly through experiments, although never on the dramatic scale surrounding black holes. The closer one comes to an intense gravitational field, the more pronounced the difference becomes. It is difficult for our everyday intuition to accept. After all, we tend to think of time as absolute, yet the universe seems to insist otherwise. Time is flexible. Time is local. Time is woven into the geometry of the cosmos itself. Gravity is not the only influence. Motion changes time as well. Imagine two identical twins. One remains on Earth, The other embarks upon a journey aboard an incredibly fast spacecraft, traveling close to the speed of light. After many years, the traveler returns home. To everyone's surprise, the traveling twin has aged less than the sibling who stayed behind. This famous thought experiment, known as the twin paradox, sounds like science fiction, yet it follows directly from Einstein's special theory of relativity. The faster an object moves through space, the more slowly time passes for it, relative to observers moving differently. Once again, the effect becomes noticeable only at extraordinary speeds. Commercial airplanes experience only tiny differences. Astronauts aboard the International Space Station age just fractions of a second differently from people on Earth. Nevertheless, these tiny differences are real. Every journey through space is also a journey through time. This leads to an extraordinary realization. The universe contains no single present moment shared equally by everyone. What feels like now for one observer may not perfectly match now for another far away. Our everyday experience hides this complexity because the differences are incredibly small under ordinary conditions. But across cosmic distances and immense gravitational fields, time reveals its remarkable flexibility. There are places where yesterday and tomorrow become far less straightforward than we imagine. Neutron stars provide another fascinating example. These collapsed stellar remnants contain more mass than our Sun packed into a sphere scarcely 20 kilometers across. Standing near one, if such a thing were somehow possible, would expose you to gravitational forces so intense that time would flow noticeably more slowly compared with regions farther away. Even light struggles to escape. Space and time become tightly curved around these extraordinary objects. Some physicists speculate that the early universe itself experienced dramatic variations in the flow of time. During the brief moments immediately following the Big Bang, conditions were so extreme that our current understanding of time begins to blur. General relativity and quantum mechanics, our two greatest theories, both attempt to describe this era, yet neither fully succeeds. Somewhere within those first fractions of a second may lie clues to an even deeper understanding of time itself. There are even more speculative ideas. Certain solutions to Einstein's equations suggest the mathematical possibility of wormholes, hypothetical tunnels connecting distant regions of space-time. If such structures could exist and remain stable, they might link not only distant places, but perhaps different moments as well. At present, no observational evidence confirms that traversable wormholes exist. They remain fascinating theoretical possibilities rather than established realities. Still, they remind us how much mystery continues to surround the nature of time. Perhaps the greatest surprise is that time does not simply pass. It participates, it stretches, it contracts, it responds. Like space itself, it is dynamic rather than fixed. This realization changes the way we think about our own lives. Each of us experiences time as a steady current carrying memories into the past and possibilities into the future. Yet from the universe's perspective, time is not one perfectly uniform river. It resembles a vast landscape whose flow changes from place to place. Mountains and valleys exist not only in space, but also within time itself. The clocks carried by astronauts, satellites, distant stars, and galaxies all tell slightly different stories. And somehow, all of those stories fit together into one magnificent cosmic tapestry. Perhaps that is one of the quiet lessons the universe offers. Reality is often far richer than appearances suggest. What seems simple may conceal astonishing depth. A second is never merely a second. It depends upon where you are, how fast you move, what gravity surrounds you. The universe is not only stranger than our ancestors imagined, it remains stranger than most of us experience every ordinary day. And yet, despite these extraordinary differences, the cosmos unfolds with remarkable harmony. Galaxies continue to spin, stars continue to shine, planets continue to orbit. Even as time itself flows differently from one corner of the universe to another, the grand symphony continues without interruption. As our journey carries us deeper into these cosmic mysteries, another question quietly awaits us. If time can bend, stretch, and slow beneath the influence of gravity, then perhaps space and time are not the deepest layers of reality after all. Could there be something even more fundamental, hidden beneath the fabric of space-time itself, patiently waiting for humanity to discover? 9. Could the universe remember its own past? What if the fabric of space quietly preserves echoes of events that happened billions of years ago? As we leave behind the strange landscapes where time bends beneath the weight of gravity, another question begins to emerge, one that is quieter, yet perhaps even more profound. If space and time can stretch, curve, and evolve, could they also remember? Not in the way living creatures remember. The universe has no brain, no thoughts, no hidden archive recording every moment that has ever unfolded. And yet, in an extraordinary sense, the cosmos does preserve traces of its own history. Every galaxy, every star, every atom, every beam of light carries information about events that happened long ago. The universe is filled with echoes. Most are silent, some are visible, others remain hidden, waiting for patient observers to uncover them. In many ways, astronomy is unlike any other science. Geologists study rocks formed millions of years ago. Biologists examine fossils preserved beneath ancient sediments. Historians read written records left by civilizations. Astronomers, however, observe history directly. Whenever we look into the night sky, we are not seeing the universe as it exists now. We are seeing it as it once was. Light does not travel instantly. Although it moves at nearly 300,000 kilometers every second, even this astonishing speed has limits. Sunlight takes about 8 minutes to reach Earth. When you watch the sun setting, you are actually seeing it as it appeared 8 minutes earlier. The nearest star beyond our sun lies over 4 light years away. Its light began traveling toward us before many children entered school. More distant stars reveal even older moments. Entire galaxies appear as they existed millions or even billions of years ago. Some of the faintest galaxies observed by modern telescopes are so distant that their light began its journey shortly after the universe itself was born. Looking deeper into space is also looking further into time. The night sky is a museum without walls. Each point of light is a message traveling across unimaginable distances. Some of those messages have been crossing the universe for nearly its entire history before finally arriving at our eyes. This remarkable fact transforms every observation into a conversation with the past. Yet light is only one kind of cosmic memory. The universe preserves other traces as well. One of the most beautiful examples surrounds us constantly, though our eyes cannot detect it. Shortly after the Big Bang, the universe was unimaginably hot. Matter and light were trapped together inside an opaque cosmic plasma. Photons bounced endlessly from one particle to another, unable to travel freely. Then, about 380,000 years after the beginning, the expanding universe cooled enough for electrons and atomic nuclei to combine into neutral atoms. Suddenly, light was released. Those ancient photons have continued traveling ever since. Today, they fill every direction in space as an incredibly faint microwave glow known as the cosmic microwave background. It is sometimes called the oldest light in the universe. Although invisible without specialized instruments, it surrounds Earth at every moment. Wherever we point a radio telescope, we encounter this ancient radiation. It is not merely a relic. It is a snapshot, a photograph of the infant universe. Tiny fluctuations within this ancient light reveal the earliest seeds from which galaxies would eventually grow. Without them, stars, planets, and perhaps life itself might never have formed. The universe has preserved an image of its own childhood for over 13 billion years. It is difficult to imagine a more remarkable memory. Even gravity may carry records of ancient events. When enormous objects accelerate, colliding black holes, merging neutron stars, exploding stars, they generate ripples in space-time itself. These ripples are known as gravitational waves. Unlike light, gravitational waves pass almost unhindered through matter. They travel across the cosmos, carrying information from places that may otherwise remain forever hidden. When scientists first detected gravitational waves in 2015, they were not simply confirming Einstein's predictions. They were listening to an event that had occurred over 1 billion years earlier. The universe had stored that information within space-time itself until delicate instruments on Earth became sensitive enough to hear it. In a sense, space-time had been carrying that ancient whisper across cosmic history. The stars themselves also remember. Every atom heavier than hydrogen and helium tells a story. Carbon within your cells, oxygen in every breath, iron flowing through your blood, calcium strengthening your bones. all of these elements were forged inside stars that lived and died long before our solar system existed. Some were created during peaceful stages of stellar evolution. Others formed in the violent explosions of supernovae. Still others may have emerged when neutron stars collided in spectacular cosmic mergers. Each atom is a traveler, carrying a history billions of years old. The iron inside your body once belonged to a star. Long before Earth formed, long before the sun ignited, that ancient star lived its brilliant life, exhausted its fuel, and scattered its enriched material across the galaxy. Eventually, those atoms gathered into new clouds of gas. New stars formed, new planets appeared, and after countless transformations, some of those same atoms became part of you. The universe recycles not only matter, but history. Every living thing carries fragments of ancient stars. Galaxies preserve memories too. Their graceful spiral arms, their clusters of old stars, their streams of disrupted companions, all reveal events that unfolded across billions of years. Astronomers can often reconstruct a galaxy's past by carefully examining its present structure. A distorted spiral may reveal an ancient collision. A halo of stars may preserve evidence of a long-vanished companion galaxy. Like archaeologists uncovering forgotten civilizations, astronomers decode these celestial clues to reconstruct stories written across cosmic time. Even our own Milky Way bears scars from previous encounters. Tiny satellite galaxies have been stretched apart by gravity, leaving long rivers of stars winding around our galaxy. These stellar streams remain visible for billions of years, preserving the memory of encounters long completed. The universe rarely erases its history completely. Instead, it layers new chapters upon older ones. Some physicists wonder whether information itself can ever truly disappear. This question became especially important when studying black holes. For many years, scientists debated whether anything falling into a black hole would vanish forever, taking its information with it. Such a loss would violate important principles of quantum mechanics. Today, many researchers believe that information is somehow preserved, although exactly how remains one of the greatest unsolved mysteries in modern physics. This puzzle, known as the black hole information paradox, continues to inspire new ideas about the deepest nature of space-time. Perhaps reality remembers more than we currently understand. Quantum physics introduces another intriguing possibility. At the smallest scales, particles behave according to probabilities rather than definite certainties. Some interpretations suggest that information about every interaction may remain woven into the quantum state of the universe itself. Whether this constitutes a true memory remains an open philosophical question. Scientists continue exploring these ideas with caution, recognizing the distinction between elegant mathematics and demonstrated reality. Still, the possibility is captivating. Perhaps the cosmos is less like a blank stage and more like a manuscript continually revised, where each chapter leaves subtle traces within the pages that follow. As telescopes become more powerful and detectors more sensitive, humanity is learning to read ever older portions of that manuscript. The James Webb Space Telescope peers farther into cosmic history than ever before. Future gravitational wave observatories may detect echoes from the universe's earliest moments. Perhaps one day, we will even glimpse signs of the mysterious era before the first stars ignited. Each discovery reveals another sentence in the universe's autobiography. And perhaps that is the quiet wonder hidden within the night sky. Nothing is ever entirely isolated. Every moment leaves consequences. Every explosion sends light outward. Every star enriches future generations. Every galaxy carries the fingerprints of its past. Even we, sitting beneath the stars in quiet reflection, are participants in this endless chain of memory. The atoms within us remember ancient suns. The light reaching our eyes remembers distant galaxies. The very fabric of space-time continues carrying whispers from events unimaginably far away. The universe does not remember in words. It remembers through light, through gravity, through matter, through the delicate patterns left behind by time itself. And as our understanding deepens, another question begins to unfold. If the cosmos preserves echoes of its past so faithfully, then perhaps its future is also quietly encoded within the laws that have guided it from the very beginning. Where, then, is the universe ultimately leading this magnificent story that has been unfolding for nearly 14 billion years? 10. Worlds that live without sunlight. Some of the most fascinating places in the universe may never have seen a sunrise. After exploring how the universe preserves echoes of its ancient past, our journey now turns toward places that challenge one of our deepest assumptions about life itself. For as long as humans have looked toward the sky, sunlight has seemed inseparable from existence. Every forest, every ocean, every flower blooming in spring, every bird crossing the morning sky, almost every living thing on Earth depends directly or indirectly upon the energy flowing outward from our sun. Its warmth drives the winds. Its light feeds plants through photosynthesis. Its energy sustains nearly every food chain on our planet. It is easy to imagine that sunlight must therefore be essential for life everywhere. But the universe often reminds us that what feels universal on Earth may be only one possibility among many. There may be entire worlds where dawn has never broken. No sunrise has ever painted the horizon. No shadows have ever stretched across a landscape beneath a bright star. Yet these worlds may still possess everything necessary for life to emerge. The idea sounds astonishing, but nature has already offered us intriguing clues. Deep beneath Earth's oceans, far beyond the reach of sunlight, lie some of the strangest ecosystems ever discovered. In 1977, scientists exploring the Pacific Ocean encountered hydrothermal vents nearly 2.5 kilometers below the surface. No sunlight reached those depths. The darkness was complete. The pressure was immense. Water emerging from the vents reached temperatures of hundreds of degrees Celsius. At first glance, such an environment seemed utterly hostile. Yet it was alive. Giant tube worms swayed gently in the currents. Blind shrimp clustered around mineral chimneys. Strange crabs and countless microorganisms flourished where no one had expected life to survive. These ecosystems did not depend upon sunlight. Instead, tiny microbes harvested energy directly from chemical reactions involving hydrogen sulfide and other compounds rising from Earth's interior. This process, known as chemosynthesis, demonstrated something extraordinary. Life does not necessarily require sunlight. It requires energy, and energy can arrive in many forms. This discovery transformed the search for life beyond Earth. Perhaps somewhere among the countless worlds orbiting distant stars, similar environments exist. Or perhaps they are even more common than sunlit planets like our own. One particularly fascinating candidate lies within our own solar system. Europa, one of Jupiter's largest moons, appears from a distance as a brilliant sphere of cracked ice. Its frozen surface reflects sunlight beautifully, giving little hint of what may lie beneath. Yet hidden below that icy shell is believed to be a vast global ocean. Some estimates suggest Europa may contain more liquid water than all of Earth's oceans combined. This ocean is sealed beneath ice that may be tens of kilometers thick. Sunlight never reaches its depths. Nevertheless, Europa is far from inactive. The immense gravity of Jupiter continuously squeezes and stretches the moon through tidal forces. This constant flexing generates internal heat. Scientists believe that warm, rocky material may interact with the ocean floor, potentially creating hydrothermal vents remarkably similar to those found on Earth. If so, chemical energy rather than sunlight could sustain simple forms of life. No one knows whether such organisms exist, but the ingredients appear surprisingly promising. Another remarkable world waits even farther away. Saturn's moon Enceladus is much smaller than Europa, yet it has become one of the most exciting places in planetary science. The Cassini spacecraft discovered towering plumes of water vapor erupting through cracks near Enceladus's south pole. These icy geysers shoot material hundreds of kilometers into space. By flying directly through the plumes, Cassini detected water, organic molecules, salts, and molecular hydrogen. Together, these ingredients suggest that warm water interacts with rocky material deep below the surface. Once again, scientists found evidence of an ocean hidden beneath ice. Once again, sunlight plays little role beneath that frozen shell. Instead, chemistry and internal heat may provide the energy needed for life. Even Titan, Saturn's largest moon, invites us to expand our imagination. Unlike Europa or Enceladus, Titan possesses a thick atmosphere and rivers, lakes, and seas. Yet these are not made of water. They consist primarily of liquid methane and ethane. At Titan's frigid surface temperature, water behaves like solid rock. Hydrocarbon liquids flow instead. Some researchers have wondered whether entirely unfamiliar forms of chemistry might operate there. Could life exist using solvents other than water? At present, there is no evidence that such life exists. Yet Titan reminds us that nature often explores possibilities beyond those we first imagine. Beyond our solar system, the diversity becomes almost overwhelming. Astronomers have now discovered thousands of exoplanets orbiting distant stars. Some resemble giant versions of Jupiter. Others are rocky worlds similar in size to Earth. Among them may be planets wandering alone through interstellar space, no longer bound to any star. These lonely bodies are sometimes called rogue planets. Without a nearby sun, they drift through permanent darkness. At first thought, such worlds appear hopelessly frozen. Yet some models suggest that thick atmospheres rich in hydrogen could trap geothermal heat escaping from the planet's interior. If enough heat remained, liquid water might survive beneath the surface despite the endless night. Imagine an ocean existing beneath an ice-covered world, drifting silently between the stars. No sunrise, no sunset. Only darkness stretching forever across the sky. And yet, perhaps, life quietly enduring below. Energy comes not from a distant star, but from the planet itself. Radioactive elements deep within the interior slowly decay, releasing heat. Residual warmth from the planet's formation continues escaping outward. Chemical reactions sustain microscopic ecosystems. The universe may contain countless hidden habitats invisible to conventional astronomy. Perhaps the most remarkable lesson is that life appears remarkably adaptable. Here on Earth, organisms thrive in boiling springs, acidic lakes, frozen deserts, deep underground mines, and beneath kilometers of Antarctic ice. Some microbes survive intense radiation. Others flourish in environments once considered completely uninhabitable. These extremophiles continually expand our understanding of where life can exist. Each new discovery encourages scientists to broaden the search beyond Earth. Instead of asking only, where is there sunlight, researchers increasingly ask, where is there energy? The distinction changes everything. Energy may arise from starlight. It may also come from geothermal heat, tidal forces, radioactive decay, or chemical reactions hidden beneath frozen crusts. Life, if it exists elsewhere, may not resemble forests, oceans, or animals familiar to us. It may consist only of microscopic organisms living patiently within dark oceans beneath kilometers of ice. Such life would never know blue skies, never witness stars, never experience the warmth of daylight. Its universe would be entirely different from ours, and yet it would still belong to the same cosmic story. Perhaps intelligence somewhere in the distant future could even evolve in such hidden oceans. What would civilization become if its people had never seen the sky? Would they imagine stars as myths? Would they believe an endless ceiling of ice marked the edge of reality? Only after developing advanced technology might they discover that above their frozen roof lies an entire universe filled with galaxies beyond counting. The thought is wonderfully humbling. Perhaps our own understanding remains equally incomplete. Perhaps there are environments throughout the cosmos so unfamiliar that we have not yet learned how to recognize them. As our instruments become more sensitive, we continue discovering worlds more varied than anyone expected only a few decades ago. Every new mission reveals another surprise. Every telescope widens the possibilities. The universe rarely rewards certainty. Instead, it rewards curiosity. And perhaps that is its quiet invitation, to remain open, to recognize that life may not require blue skies, green forests, or even sunlight itself. What truly matters may be something far simpler: a source of energy, a stable environment, enough time. Given those ingredients, nature has repeatedly demonstrated an astonishing capacity for creativity. Some of the most extraordinary worlds may therefore be hidden, not beneath bright suns, but beneath silent oceans, frozen crusts, and eternal darkness. places where morning has never arrived, places where no creature has ever watched a sunrise. Yet perhaps in those unseen depths, life patiently continues its ancient work, unaware that somewhere far above, across unimaginable distances, another small world circles a yellow star and wonders whether it is alone. And as we continue our gentle voyage through the universe, another mystery quietly comes into view. If life can flourish even without sunlight, perhaps the next question is not merely where life exists, but whether the universe itself has been creating the conditions for life far longer and in far more places than humanity has ever dared to imagine. 11. The cosmic weather that shapes entire galaxies. Galaxies are not peaceful islands of stars. They are places where invisible storms rage across millions of light years. As we leave behind the hidden worlds that thrive without sunlight, our attention slowly expands once more. From the quiet darkness beneath frozen oceans to the immense architecture of entire galaxies. From our human perspective, galaxies often appear serene. Photographs captured by powerful telescopes reveal elegant spirals, glowing nebulae, and rivers of starlight flowing across the darkness. Everything seems calm, timeless, almost frozen. Yet this tranquility is an illusion born from distance. If we could somehow watch a galaxy unfold over millions of years, we would witness an environment filled with motion, turbulence, and colossal forces beyond anything the human imagination naturally conceives. Galaxies possess their own kind of weather, not weather made of rain, snow, or hurricanes, but weather composed of magnetic fields, shock waves, radiation, cosmic rays, and rivers of superheated gas stretching across unimaginable distances. Invisible storms continuously reshape the lives of stars. They determine where new suns will be born, where planets may someday emerge, and where entire regions of space will remain forever silent. Unlike Earth's atmosphere, the gas between stars is extraordinarily thin. In fact, much of what astronomers call empty space inside galaxies contains only a few atoms per cubic centimeter. By earthly standards, it would qualify as an almost perfect vacuum. Yet over millions of light years, even this incredibly sparse material becomes significant. Entire galaxies float within enormous clouds of hydrogen. These clouds drift, collide, compress, and expand in slow motion across cosmic time. Sometimes they remain quiet for hundreds of millions of years. Then something disturbs the balance. A nearby supernova explodes. A spiral arm passes through. Gravity gently gathers scattered gas into denser regions. Gradually, invisible pressure waves move through the cloud. Like weather fronts crossing Earth's skies, these galactic disturbances change everything. As gas compresses, gravity begins taking over. Tiny fluctuations become larger. Small clumps attract more material. Eventually, enormous molecular clouds emerge. These are among the coldest places in galaxies. Temperatures may fall to only a few degrees above absolute zero. Yet paradoxically, these frozen clouds become the birthplaces of stars. Within their dark interiors, gravity patiently sculpts new solar systems. The weather of a galaxy is therefore not merely decorative. It determines where creation itself begins. Sometimes, however, the opposite occurs. Instead of encouraging new stars, galactic weather can suppress them. Massive young stars emit powerful ultraviolet radiation. Their fierce stellar winds blow surrounding gas outward at millions of kilometers per hour. When several giant stars form close together, their combined radiation carves enormous cavities into the surrounding interstellar medium. These expanding bubbles may stretch for hundreds of light years. Inside them, much of the raw material needed for future star formation has been swept away. In one region, weather creates stars. In another, it prevents them. The galaxy constantly balances between construction and destruction. Perhaps the most dramatic weather events occur when stars reach the ends of their lives. A supernova is not simply an explosion. It is a shockwave powerful enough to reshape vast neighborhoods of space. For a brief moment, a single dying star may outshine billions of others. The expanding debris races outward for tens of thousands of years. As it moves, it compresses nearby clouds while enriching them with heavy elements: iron, calcium, silicon, oxygen, carbon. Many of the atoms within our own bodies were forged inside ancient stars before being scattered by supernova explosions long before Earth even existed. In this sense, Every supernova is both an ending and a beginning. The explosion destroys one star while preparing the ingredients for countless future worlds. Cosmic weather is therefore deeply connected to the cycle of existence itself. Even more mysterious are the magnetic fields that thread through entire galaxies. Unlike the familiar magnets on a refrigerator door, galactic magnetic fields are astonishingly subtle. Their strength is incredibly weak by terrestrial standards. Yet because they extend across millions of light years, their influence becomes profound. Charged particles spiral along invisible magnetic pathways. Clouds of plasma follow intricate patterns shaped by these fields. Radio telescopes have revealed magnificent magnetic structures stretching across spiral arms like unseen rivers flowing beneath the visible galaxy. We cannot observe these currents with human eyes, yet they quietly organize the movement of matter across enormous distances. Then there are cosmic rays. Despite the name, they are not rays of light. Most are tiny atomic particles accelerated to nearly the speed of light by supernovae, pulsars, and perhaps even supermassive black holes. These energetic particles travel throughout galaxies for millions of years. Some eventually reach Earth. Every second, countless cosmic rays pass harmlessly through your body. Most are blocked by Earth's atmosphere before they can reach the surface. Without our atmosphere and magnetic field, life would face a far harsher environment. The galaxy itself is constantly filled with this invisible rain. Some scientists even suspect that cosmic rays influence how molecular clouds collapse, subtly affecting the rate at which stars form. The weather of a galaxy may therefore reach into the very process of creation. At the centers of many galaxies lies another extraordinary source of cosmic storms: supermassive black holes. Although black holes themselves emit no light, the material falling toward them often shines with astonishing brilliance. As gas spirals inward, friction heats it to millions of degrees. Before disappearing beyond the event horizon, some of this matter is redirected into colossal jets shooting outward from the galaxy's core. These jets travel close to the speed of light. Some extend for hundreds of thousands of light years. Others exceed the diameter of the galaxy itself. Like gigantic cosmic blowtorches, they inject enormous amounts of energy into surrounding space. Surprisingly, these outflows may help regulate galactic evolution. Without them, gas might cool too quickly, causing stars to form uncontrollably. With them, star formation slows. The black hole becomes not merely a destroyer, but also an unexpected architect, maintaining balance within the galaxy. Astronomers sometimes describe this process as feedback. The galaxy and its central black hole continuously influence one another in an intricate cosmic conversation lasting billions of years. Even galaxies themselves experience weather as they travel through the universe. Many belong to clusters containing hundreds or even thousands of neighboring galaxies. These clusters are not empty. They are immersed in extremely hot gas, reaching tens of millions of degrees. As galaxies move through this environment, the surrounding gas exerts pressure. Over immense periods, it can strip away the galaxy's own reservoirs of star-forming material. A once vibrant spiral galaxy may gradually lose its ability to produce new stars. Its brilliant blue populations fade. Older red stars begin to dominate. The galaxy grows quieter, not because time alone has passed, but because its environment has changed. Just as climate influences ecosystems on Earth, the larger cosmic environment influences the evolution of galaxies. Perhaps the most beautiful aspect of cosmic weather is its timescale. On Earth, storms pass within hours or days. Seasons unfold over months. Climate changes across centuries. Galactic weather unfolds across millions of years. The clouds move almost imperceptibly. Shock waves expand with extraordinary speed, yet still require tens of thousands of years to cross nearby stellar neighborhoods. Entire cycles of star birth and stellar death span hundreds of millions of years. To us, the galaxy appears frozen, but only because our lives are far too brief to witness its gentle transformations. If a human life were compressed into a single heartbeat, galactic weather would resemble the slow growth of mountains, almost invisible, yet relentlessly shaping everything. This perspective invites a quiet sense of humility. We often think of the universe as static because our own existence occupies only a tiny instant within its history. But nature is never truly still. Even in the darkest regions between stars, invisible forces continue their patient work. Gas drifts, magnetic fields twist, radiation spreads, shock waves travel, gravity gathers. New suns prepare to ignite, old ones quietly fade. The galaxy breathes in rhythms so vast that only careful observation across generations allows us to perceive its motion. Modern observatories, combining radio waves, infrared light, X-rays, and gamma rays, have gradually uncovered these hidden storms. Each wavelength reveals another layer of the galactic atmosphere. Together, they remind us that reality extends far beyond what our eyes alone can perceive. Perhaps that is the greatest lesson hidden within cosmic weather. Much of what shapes the universe remains invisible, not absent, simply beyond ordinary perception. The same may often be true in our own lives. The most powerful forces are not always the loudest or the brightest. Sometimes they are the quiet influences that patiently shape the future over long stretches of time. Across millions of light years, invisible storms continue sculpting galaxies with extraordinary precision. They determine where stars will shine, where planets may someday form, and where the raw ingredients for life will gather once again. And as our journey moves onward, another profound mystery begins to emerge. If galaxies themselves are shaped by these immense invisible forces, perhaps the universe is not simply expanding through space, but participating in an even larger cosmic dance, whose rhythm stretches beyond anything we have yet discovered. 12. The day the universe finally grows quiet. Imagine a future where every star has faded and silence becomes the brightest thing left in existence. Throughout our journey, we have wandered across luminous galaxies, hidden oceans beneath frozen worlds, invisible storms stretching between the stars, and the quiet forces that patiently shape the architecture of the cosmos. Every chapter has revealed a universe that feels endlessly alive. Stars ignite, galaxies collide, nebulae bloom into brilliant nurseries. Black holes feed, planets cool. Life, perhaps, quietly awakens somewhere beneath unfamiliar skies. It is easy to imagine that this magnificent activity will continue forever. After all, the night sky has always been filled with stars. For every generation that has ever looked upward, the heavens appeared eternal. Yet modern cosmology tells a gentler, more bittersweet story. The universe is changing, not suddenly, not violently, but with extraordinary patience. If we could fast forward trillions upon trillions of years into the future, we would witness something almost impossible for the human mind to grasp. The universe would slowly become quieter, not because something catastrophic destroyed it, but because it simply grew old. Everything in nature follows cycles. Trees blossom before their leaves fall. Mountains slowly erode. Oceans reshape coastlines grain by grain. Even stars, those seemingly eternal lights, are temporary travelers across cosmic history. Every star shines by transforming hydrogen into helium deep within its core. This process releases enormous amounts of energy. For billions of years, gravity pulls inward while nuclear fusion pushes outward. The two remain in delicate balance, but the fuel is finite. Eventually, every star reaches the moment when its internal fires begin to fade. Massive stars burn quickly. Some survive only a few million years before ending in spectacular supernova explosions. Smaller stars live much longer. Our own sun will continue shining for roughly another 5 billion years. Tiny red dwarfs, however, are astonishingly efficient. Some may continue burning for trillions of years, far longer than the current age of the universe itself. Ironically, these humble stars, almost invisible to the naked eye, may become the final natural lights in existence. As cosmic time stretches onward, galaxies will gradually exhaust the cold gas needed to create new stars. Every generation of stellar birth consumes a little more of this precious material. Some gas becomes locked inside planets. Some is blown away by supernovae. Some falls into black holes. Eventually, the giant molecular clouds that once gave birth to countless suns become increasingly rare. The brilliant stellar nurseries that now decorate galaxies with glowing pink and blue clouds slowly disappear. No catastrophe announces their end. They simply stop appearing. Astronomers sometimes call this period the stelliferous era, the age when stars dominate the universe. Remarkably, we happen to live near its peak. The Milky Way is still actively creating stars. Distant galaxies continue producing new generations of suns. We inhabit one of the brightest chapters in cosmic history. Future observers, if any still exist, may look back upon our era as a time of extraordinary abundance. But abundance never lasts forever. As trillions of years pass, star formation gradually slows. The universe enters what some scientists describe as the degenerate era. By then, almost every familiar star has completed its life cycle. The great spiral galaxies no longer sparkle with countless young blue stars. Instead, they become collections of stellar remnants: white dwarfs, neutron stars, black holes, brown dwarfs. These quiet survivors drift through increasingly dark galaxies. White dwarfs slowly cool for unimaginable lengths of time. Without nuclear fusion, they possess no internal source of new energy. They simply radiate away the heat stored during their former lives. At first they glow white, then yellow, then orange, eventually red. Finally, after trillions upon trillions of years, they become what physicists call black dwarfs. These objects are purely theoretical today because the universe is not yet old enough for even one to have formed. None exist. Not yet. But someday, they may become among the most common objects in the cosmos. Even black holes, often imagined as eternal, are not truly permanent. In 1974, physicist Stephen Hawking introduced one of the most surprising ideas in modern science. According to quantum theory, black holes should slowly lose energy through an incredibly subtle process now known as Hawking radiation. The effect is unimaginably weak. A black hole as massive as the Sun would require roughly 10 to the power of 67 years to evaporate completely. Supermassive black holes would survive vastly longer, perhaps 10 to the power of 100 years or more. These numbers are so enormous that ordinary language almost loses meaning. Compared to such timescales, the entire history of human civilization lasts less than a blink. Yet even these giants are not immortal. Given enough time, they too disappear, little by little, particle by particle, until nothing remains. As stars vanish and black holes slowly fade, darkness spreads naturally across the universe. This darkness is unlike the night skies we know today. Modern night is rich with distant galaxies, invisible radiation, scattered starlight. Future darkness becomes almost absolute. The expanding universe steadily carries galaxies farther apart. Because space itself continues stretching, distant galaxies eventually move beyond each other's observable horizons. Future civilizations, living trillions of years from now, might see only their own isolated galaxy. Every other island of stars would have disappeared beyond reach. Not destroyed, simply carried away by the expansion of space faster than light can bridge the growing distance. The universe becomes lonelier, not through violence, but through separation. Silence gradually replaces conversation across the cosmos. Even atoms themselves may not endure forever. Some theories suggest that protons, the building blocks of ordinary matter, might eventually decay. If proton decay truly occurs, then after astonishingly long periods, planets, rocks, stars, and even the remnants of dead galaxies slowly dissolve into lighter particles. This prediction remains unconfirmed. Experiments continue searching for evidence. So far, no proton has ever been observed to decay. Yet if nature allows it, the far future becomes stranger still. Matter itself quietly unravels. The universe approaches extraordinary simplicity. Energy becomes thinly distributed. Particles drift through almost limitless emptiness. The great structures that once filled the heavens have faded into memory. Physicists sometimes describe this ultimate destination as heat death. The phrase sounds dramatic, yet it does not involve fire. Instead, it describes a universe that has reached maximum entropy. Energy still exists, but it is spread so evenly that no useful work can be extracted from it. There are no temperature differences to drive engines, no collapsing clouds to ignite new stars, No organized systems capable of sustaining complexity as we understand it. Everything settles into quiet equilibrium. It is less an explosion than a long exhale, a gradual easing towards stillness. For many people, this vision initially feels sad. A future without stars, without galaxies blazing across the darkness, without new worlds forming beneath swirling nebulae. Yet another perspective is possible. Nothing in nature lasts forever. Impermanence is woven into every level of existence. Flowers bloom because they eventually fade. Stars shine because they slowly consume their fuel. Life becomes precious precisely because time is limited. The eventual quiet of the universe does not diminish the beauty of its present. If anything, it deepens our appreciation. We are fortunate enough to exist during an age when galaxies still sparkle, when planets still form, when heavy elements continue building new possibilities, when the universe remains astonishingly creative. Perhaps there is also comfort in recognizing that the cosmos itself follows a gentle rhythm. It is born, it grows, it changes, it ages, and eventually it rests, not unlike living things, not unlike civilizations, not unlike ourselves. The universe, despite its unimaginable scale, participates in the same quiet cycles found throughout nature. Its ending, if heat death truly awaits, is not one of chaos. It is one of profound stillness, a silence earned after an almost inconceivable history of creation. And perhaps silence should not always be mistaken for emptiness. In the stillness of a sleeping forest, countless stories remain hidden. In the silence between musical notes, beauty often becomes more powerful. Likewise, the quiet future of the cosmos may represent not failure, but completion, a masterpiece that has finished its final movement. As we contemplate that distant future, another question naturally begins to emerge. If the universe truly moves towards silence with such remarkable patience, then what first awakened it from silence in the beginning? What happened before the first stars, before the first galaxies, before even space and time themselves learned how to unfold? That mystery waits patiently at the threshold of our final journey. 13. The mysteries hidden inside light. Every beam of light reaching your eyes carries an ancient message that traveled farther than imagination can easily grasp. After imagining the unimaginably distant future, a universe where the last stars have faded and silence stretches across eternity, we now turn our attention towards something far more familiar, something that has quietly accompanied every moment of our lives: light. We rarely stop to think about it. Every morning, sunlight pours through windows without asking for our attention. Every evening, distant stars decorate the sky with tiny points of brightness. The glow of a candle, the shimmer of moonlight on calm water, the soft colors of sunrise, the brilliant arc of a rainbow after rain. Light feels ordinary because it surrounds us constantly. Yet hidden inside every beam of light is an extraordinary story. Unlike sound, which requires air or water to travel, light moves effortlessly through the vacuum of space. Across billions of kilometers, across entire galaxies, across the expanding universe itself. When you look at the night sky, you are not seeing the universe as it exists at this very moment. You are seeing history. Every photon arriving at your eyes has spent time traveling through space. Light from the moon takes just over 1 second to reach Earth. Sunlight requires about 8 minutes. The nearest star beyond our sun sends its light across more than 4 years before it finally arrives. The glowing center of our Milky Way appears as it existed roughly 26,000 years ago. Some galaxies, visible through modern telescopes, are seen as they were billions of years in the past, long before our own planet had even formed. In a sense, astronomy is unlike any other science. Most sciences study the present. Astronomy studies memory. Every telescope is also a time machine. The farther we look into space, the farther back into history we travel. This remarkable fact transforms every observation into an ancient message. Imagine receiving a letter written thousands of years ago. Now imagine receiving one written billions of years before humanity existed. That is precisely what every photon from a distant galaxy represents: an ancient messenger, patiently crossing unimaginable distances, never stopping, never resting, simply moving forward at nature's ultimate speed. Light travels at approximately 300,000 kilometers every second. Nothing known in the universe moves faster. This speed is so extraordinary that a single second is enough for light to circle Earth more than 7 times. Yet despite this breathtaking pace, the universe is so immense that even light requires millions or billions of years to cross it. Distance in astronomy is therefore often measured not in kilometers, but in light years. A light year is not a measure of time, it is a measure of distance. It describes how far light can travel in 1 year, nearly 10 trillion kilometers. These numbers are almost impossible to visualize. Instead, perhaps it is easier to imagine every photon as a tireless traveler. A photon born deep within a star begins an astonishing journey. Curiously, even escaping the star itself is not simple. Inside the sun, for example, light produced in the core does not immediately stream into space. Instead, it is repeatedly absorbed and re-emitted by countless atoms. Each interaction changes its direction, forward, backward, sideways, again and again. Scientists estimate that a photon may spend tens of thousands or even hundreds of thousands of years wandering through the sun's dense interior before finally reaching its surface. Once free, however, its journey becomes astonishingly swift. 8 minutes later, it reaches Earth. Some of those photons strike oceans, some warm forests, some become food through photosynthesis, some bounce from clouds into your eyes, allowing you to see the world around you. The light illuminating your face today may have begun its journey before the earliest human civilizations appeared. Every sunrise is therefore both immediate and ancient. Light also carries information, far more information than our eyes alone can perceive. To us, sunlight appears white, yet when passed through a prism, it separates into countless colors. Each wavelength reveals something different. Astronomers use this hidden language to understand stars they can never visit. When starlight passes through a telescope and into a spectroscope, it forms delicate patterns known as spectral lines. Each chemical element leaves its own unmistakable signature. Hydrogen, helium, carbon, iron, calcium, sodium. Every atom interacts with light in a unique way. It is rather like listening to an orchestra in which every instrument produces a recognizable sound. Even from far away, you know which instrument is playing. Likewise, astronomers can identify the elements inside distant stars simply by studying their light. Without touching them, without traveling there, without collecting a single physical sample. Everything is written into the light itself. Even motion leaves its mark. When an object moves toward us, its light shifts slightly toward shorter wavelengths. When it moves away, the light stretches toward longer wavelengths. This phenomenon, known as the Doppler effect, allows astronomers to measure the movement of stars, galaxies, and even planets orbiting distant suns. Through these tiny shifts in color, scientists discovered one of the greatest revelations in modern cosmology. Nearly every distant galaxy is moving away from us, not because Earth occupies a special place, but because space itself is expanding. The universe is not static. It is growing larger every moment. All of this profound knowledge emerged from studying light. Light also tells stories of violence. When massive stars explode as supernovae, they briefly outshine entire galaxies. Their brilliant flashes race across the universe, carrying evidence of enormous explosions. By examining these flashes, astronomers have measured cosmic distances and uncovered the mysterious acceleration of the universe's expansion. Light, in this way, became the messenger that revealed the existence of dark energy, a phenomenon we still struggle to understand. Elsewhere, invisible forms of light reveal entirely different realities. Human eyes detect only a tiny portion of the electromagnetic spectrum. Visible light occupies an almost insignificant band between longer infrared waves and shorter ultraviolet rays. Beyond them lie radio waves, microwaves, X-rays, and gamma rays. Each uncovers another hidden universe. Radio telescopes reveal enormous clouds of hydrogen drifting through interstellar space. Infrared observatories peer through thick curtains of dust to witness newborn stars still hidden inside their stellar nurseries. X-ray telescopes uncover gas heated to millions of degrees around black holes and neutron stars. Gamma-ray observatories detect the most energetic explosions known in nature. If our eyes naturally perceived every wavelength at once, the night sky would appear unimaginably complex. Invisible rivers of radiation would crisscross the heavens. Galaxies would glow in entirely unfamiliar colors. Space would seem far less empty than it appears now. In truth, the universe is constantly speaking. We simply hear only one small part of its language. Perhaps the most ancient light of all fills the entire cosmos. Long before stars existed, before galaxies assembled, before planets formed, the young universe itself glowed brilliantly. As it expanded and cooled, this ancient light stretched into microwave wavelengths. Today, it surrounds us from every direction. Astronomers call it the cosmic microwave background. It is sometimes described as the afterglow of the universe's infancy. Every television antenna, every radio observatory, every sensitive detector quietly exists within this sea of primordial light. It has traveled for more than 13 billion years. It began its journey before the Milky Way existed, before the sun, before Earth, before life. When we detect these faint microwaves, we are listening to one of the oldest surviving whispers in existence. It is difficult not to feel humbled by such a realization. Every beam of light entering your eyes tonight may have crossed unimaginable distances simply to arrive at this single moment. Some photons reflected from nearby trees began their journey only fractions of a second ago. Others left distant galaxies before multicellular life evolved on Earth. Yet they all meet together upon your retina. The present moment becomes a gathering place for countless histories. Light reminds us that the universe is deeply connected across both space and time. Nothing shines only for itself. Every star sends its story outward. Every galaxy contributes another chapter. Every photon becomes a messenger, carrying news from places we may never visit. Perhaps this is why looking up at the night sky often inspires such quiet reflection. We are not merely observing distant objects. We are reading ancient letters written across the fabric of the cosmos, letters that have crossed billions of years without losing their message. And as extraordinary as light may be, it still leaves us with one final mystery. If light reveals so much about the universe, what then remains forever hidden in the darkness where light can never escape? That question leads us naturally toward one of the most fascinating frontiers in modern astronomy, the strange realms where even light itself reaches the end of its journey. 14. The last observers in the distant future. One day, the universe may become so vast that future civilizations could never discover how it truly began. As we ended our previous journey, we reflected on light as the universe's oldest messenger. Every photon carried a memory. Every distant galaxy became a page from cosmic history. By reading the language of light, humanity slowly uncovered the story of an expanding universe, the birth of stars, and even the faint afterglow left behind by the earliest moments after the Big Bang. It is tempting to believe that this knowledge will always remain available. After all, once a discovery has been made, surely it belongs forever to every future civilization. Surprisingly, modern cosmology suggests something very different. Knowledge itself may have a lifetime. There may come an age when the evidence that allowed us to understand the universe simply disappears, not because it was destroyed, not because anyone forgot, but because the universe quietly carried it beyond reach. In many ways, we may be living during a remarkably fortunate moment in cosmic history. Our telescopes can observe billions of galaxies scattered across every direction. They reveal an expanding universe filled with structure on unimaginable scales. The faint glow of the cosmic microwave background still surrounds us, providing an ancient photograph of the universe only a few 100,000 years after its beginning. The chemical composition of stars preserves clues about generations of stellar evolution. Even the large-scale arrangement of galaxies tells us how gravity has shaped the cosmos for billions of years. These pieces fit together like an enormous puzzle. Slowly, patiently, humanity has learned to read it. But puzzles require pieces, and in the distant future, many of those pieces may no longer exist within any observer's reach. To understand why, we must remember that space itself is expanding. This expansion is not like galaxies flying through empty space. Rather, the fabric of space stretches, gently increasing the distance between galaxies over time. For nearby galaxies, gravity often overcomes this expansion. Our own Milky Way and the Andromeda Galaxy, for example, are moving toward one another. Several billion years from now, they are expected to merge into a single larger galaxy. Many neighboring dwarf galaxies will also become part of this growing family. Together, they will form one immense galactic system. Yet beyond our local neighborhood, the story unfolds very differently. Most distant galaxies continue moving farther away as the universe expands. And because this expansion is accelerating, driven by what astronomers call dark energy, those galaxies gradually recede ever faster. Eventually, they cross a profound boundary known as the cosmological horizon. Beyond this horizon, the expansion of space carries them away so rapidly that the light they emit can never reach us again. They are not destroyed, they simply become permanently inaccessible. Imagine standing on a vast shoreline at sunset. Small boats drift farther and farther into the distance. At first, they remain visible. Then they become tiny specks. Eventually, they disappear beyond the horizon. The boats continue their journeys, but from your perspective, they are gone forever. The future universe behaves in much the same way, except the ocean is space itself, and the horizon grows ever more isolating. After tens or perhaps hundreds of billions of years, nearly every galaxy outside the local group will have vanished beyond the observable universe. The night sky will change in a way almost impossible for us to imagine. Today, powerful telescopes reveal countless galaxies, filling every tiny patch of darkness. Future astronomers may see only one, their own. The magnificent cosmic web that we now study will have disappeared from view. Without those distant galaxies, one of the strongest pieces of evidence for cosmic expansion vanishes. There will be nothing obvious to suggest that the universe is growing larger. To future observers, the cosmos may appear static, calm, unchanging. Their measurements would be careful, their mathematics elegant, their observations precise. Yet despite all their intelligence, they might arrive at conclusions fundamentally different from ours. Not because they are less capable, but because the universe has hidden the evidence. Another priceless clue will also fade. The cosmic microwave background, often described as the oldest light in existence, continues stretching as the universe expands. Its wavelength grows longer, its energy decreases. Over unimaginable spans of time, it becomes so weak and so diffuse that detecting it may become effectively impossible. Eventually, even the most sensitive instruments conceivable may find only silence where once there was a brilliant relic of creation. Without that ancient glow, future scientists may never realize that the universe was once hot and dense. The earliest chapter of cosmic history could become invisible. There is another challenge as well. As stars continue evolving over trillions of years, the chemical composition of galaxies gradually changes. Many of the oldest stellar populations that preserve evidence of the universe's youth disappear. New generations of stars recycle ancient material again and again. The record becomes increasingly difficult to interpret. It is rather like attempting to reconstruct Earth's earliest history after every mountain has eroded, every fossil has vanished, and every continent has been reshaped beyond recognition. Nature leaves clues, but not forever. Some scientists have explored this remarkable possibility through thought experiments. Imagine an advanced civilization living 100 billion years from now. Its astronomers possess technology beyond anything humanity can currently imagine. Their telescopes are flawless. Their detectors approach perfect sensitivity. Their mathematics surpasses ours in every respect. Yet despite all these advantages, they may conclude that the universe consists only of their own isolated galaxy, surrounded by empty, eternal darkness. No expanding universe, no distant galaxies, no primordial background radiation, no obvious evidence of a beginning. Ironically, they could know less about the origin of the cosmos than we do today. This possibility carries a quiet philosophical lesson. Knowledge depends not only upon intelligence, it also depends upon opportunity. Nature does not reveal every truth equally across all eras. Some discoveries become possible only during narrow windows of cosmic history. Perhaps we are fortunate enough to exist within one of those windows. There is something deeply humbling about this thought. For centuries, humanity often imagined itself living at an ordinary moment. We are not at the center of space. Our sun is an ordinary star. Our galaxy is one among hundreds of billions. Yet in terms of observation, our era may be extraordinarily privileged. The universe is old enough to have formed galaxies, planets, and life, but still young enough that the evidence of its beginning remains visible. We occupy a remarkable balance point between past and future. Even our own existence depends upon timing. Had intelligent life emerged billions of years earlier, many heavy elements essential for rocky planets and complex chemistry might not yet have existed. Had it emerged hundreds of billions of years later, much of the observable universe would already have disappeared from view. It seems that curiosity itself has arrived at precisely the moment when the cosmos is still willing to answer. Perhaps this is one of the quietest wonders of all. The universe is not only something we observe. It also shapes what can be known. It determines which questions can be answered and which mysteries remain forever beyond reach. In that sense, every civilization experiences its own version of the cosmos, not because reality changes, but because the available evidence changes. We often imagine scientific progress as an endless staircase leading upward, and in many ways it is. Each generation builds upon the discoveries of those before it. Yet the distant future reminds us that some doors may quietly close, even as others continue opening. Progress is not only about learning new things. Sometimes it is also about preserving the knowledge that can no longer be rediscovered. Perhaps somewhere in that unimaginably distant future, the last observers will stand beneath an almost empty sky. They will gaze upward with the same sense of wonder that humans feel today. They will ask where everything came from. They will search for answers with extraordinary dedication. They may formulate beautiful theories, invent astonishing instruments, dream bold dreams. And yet the universe, transformed by time itself, may answer only with silence. Still, there is comfort in knowing that the story has already been read. Across one brief chapter of cosmic history, a small civilization orbiting an ordinary yellow star learned to decipher ancient light, measure the expansion of space, and glimpse the universe's earliest memories. For a fleeting moment between the birth of galaxies and their disappearance beyond the cosmic horizon, the universe allowed itself to be understood. And perhaps that is one of its greatest gifts. As our journey approaches its final chapters, one last mystery gently emerges from the darkness. If the universe changes what can be observed over time, then perhaps reality itself is even richer than anything visible. What hidden layers of existence might still surround us at this very moment, present, influential, yet forever beyond the reach of light? 15. Beyond the horizon of knowledge. Perhaps the most remarkable discovery of modern science is not how much we have learned, but how clearly we can now see the boundaries of what we may never know. For thousands of years, humanity believed every mystery simply awaited a clever enough explanation. Mountains became understandable through geology. Lightning became electricity. The planets ceased to be wandering gods and became worlds governed by gravity. Every generation watched another piece of ignorance disappear beneath the expanding light of knowledge. It became tempting to believe that science was merely a very long staircase leading upward forever. Yet the deeper we climbed, the stranger the landscape became. Instead of finding a final floor where every answer waited, we encountered locked doors built into reality itself. The universe, it seems, is willing to reveal astonishing truths, but only up to certain limits. Beyond those limits lies silence. One of those limits is astonishingly simple. We cannot observe anything traveling faster than light. This isn't merely a technological inconvenience. It is woven into the structure of space-time itself. Every telescope ever constructed, from Galileo's tiny refractor to the James Webb Space Telescope, depends upon one messenger: light. Every image of a galaxy, every spectrum of a distant star, every photograph of a nebula, every glimpse of the early universe arrives because photons have traveled unimaginable distances to reach us. But light has a speed, and because it has a speed, information has a speed. That means there are places in the universe whose light has never had enough time to arrive. There are regions forever hidden, simply because the universe has not existed long enough for their messages to reach Earth. Even more astonishingly, because space itself expands, some regions are now receding faster than light. Not because they are moving through space so quickly, but because space between us continually stretches. Their ancient light may still be on its way, but the light they emit today will never reach us. Those galaxies have not disappeared. They have merely crossed beyond our cosmic horizon. Imagine standing on a shoreline wrapped in dense fog. Ships continue sailing. Some remain visible, others slowly fade. Eventually, they vanish completely, not because they sank, but because the fog has hidden them forever. Our observable universe is much like that fog. Beyond it, the ocean almost certainly continues, but no signal can cross the distance. Another limit emerges not from space, but from time. The earliest moments after the Big Bang remain hidden behind a wall of extraordinary energy. The cosmic microwave background, often called the oldest light in the universe, formed roughly 380,000 years after the Big Bang. Before that moment, the universe was so hot that light could not travel freely. It scattered endlessly among charged particles, making the young cosmos opaque. The universe was not dark. It was brilliantly bright, too bright for light itself to escape. No optical telescope can ever look earlier than this barrier. To peer beyond it, scientists must search for entirely different messengers. Gravitational waves, neutrinos, subtle quantum fingerprints. Each offers hope of seeing deeper into cosmic history. Yet even these may eventually encounter limits beyond which information simply no longer exists. Then there is the mystery of black holes. General relativity predicts that information falling into a black hole eventually reaches the singularity. Quantum mechanics insists information cannot truly disappear. For decades, physicists have wrestled with this contradiction. Where does the information go? Is it encoded on the event horizon? Does it emerge through Hawking radiation? Or does our understanding of spacetime itself require revision? The black hole information paradox remains one of the greatest unresolved problems in theoretical physics. Its solution may reshape our understanding of reality itself. Even quantum mechanics introduces boundaries unlike anything imagined before. Werner Heisenberg's uncertainty principle tells us that certain pairs of physical quantities cannot both be known with perfect precision. This is not a limitation of measurement. It is not because our instruments are imperfect. Reality itself refuses to possess exact values for both simultaneously. Nature does not merely hide certain details. It declines to define them. At the smallest scales imaginable, certainty dissolves into probability. The universe becomes less like a machine and more like an unfolding tapestry of possibilities. Then comes mathematics, the language through which science describes the cosmos. For centuries, mathematics appeared limitless. Surely every true statement could eventually be proven. Then, in the 20th century, Kurt Gödel shattered that comforting belief. His incompleteness theorems demonstrated that within any sufficiently powerful mathematical system, there exist true statements that cannot be proven using the rules of that system. Truth, astonishingly, extends beyond proof. If mathematics itself contains unreachable truths, perhaps the universe does as well. Perhaps reality possesses questions that no civilization, however advanced, can ever answer. Questions that lie forever beyond logical reach. Physics has discovered similar hints. Certain constants appear fundamental. Why does the electron possess exactly its observed mass? Why does gravity have precisely its strength? Why are there 3 spatial dimensions rather than 4 or 11 at human scales? Why do the laws of nature take the form they do, instead of countless alternatives? Some theories attempt explanations. Others invoke deeper symmetries. Still others suggest an enormous multiverse where every possibility exists somewhere. Yet without observational evidence, many of these ideas remain forever speculative. There is a profound difference between something being possible and something being knowable. Science thrives where evidence can decide. Beyond that boundary, imagination begins to outrun observation. Perhaps nowhere is this more humbling than in the question of why there is something rather than nothing. Every scientific explanation traces one phenomenon back to another. Stars form because gravity gathers gas. Atoms exist because quantum fields allow stable particles. Galaxies emerge through cosmic evolution. But eventually, every chain of explanation approaches its beginning. Why do quantum fields exist? Why do physical laws exist? Why does existence exist at all? These questions may not simply be unanswered. They may belong to an entirely different category, questions whose answers cannot exist within the universe they describe. Just as characters inside a novel cannot fully explain the existence of the author, perhaps beings inside the universe cannot completely explain the existence of the universe itself. Yet this possibility does not diminish science. It elevates it. Science is remarkable precisely because it recognizes the difference between mystery and ignorance. Ignorance says we do not know yet. Mystery whispers, perhaps this question has no observable answer. Recognizing that distinction requires extraordinary intellectual humility. Every major scientific revolution has begun with someone admitting that previous assumptions might be incomplete. Certainty rarely produces discovery. Curiosity does. In many ways, the horizon of knowledge resembles the physical horizon at sea. As explorers sailed farther, the horizon retreated. It never disappeared. Every answer opened new questions beyond it. The same pattern defines modern cosmology. The discovery of galaxies raised questions about dark matter. Dark matter pointed toward dark energy. Dark energy raised questions about cosmic acceleration. Each solution revealed deeper mysteries waiting beyond. Knowledge expands. So does wonder. Perhaps this is not a flaw in the universe. Perhaps it is one of its greatest gifts. A completely understandable cosmos might eventually become predictable, familiar, even ordinary. Instead, reality continues to surprise us. Every generation inherits unanswered questions from the one before. Every discovery enlarges the frontier. Every telescope peers into darkness that soon becomes filled with unexpected light. And beyond that light waits another darkness inviting exploration. The horizon never ends. Perhaps it was never meant to. Because the true measure of intelligence is not possessing every answer. It is continuing to ask meaningful questions, even after discovering how vast the unknown truly is. In that sense, humanity's greatest achievement may never be reaching the end of knowledge. It may simply be refusing to stop searching. And somewhere, beyond every horizon we can currently imagine, the universe still keeps its oldest secrets, waiting patiently for minds courageous enough to ask the next impossible question. 16. The universe that never truly ends. Every answer we discover seems to uncover an even deeper mystery waiting quietly beyond it. Throughout this journey, we have traveled farther than any spacecraft could ever hope to reach. We have witnessed the birth of stars from cold clouds of gas drifting through silent darkness. We have followed galaxies as they collided, merged, and slowly reshaped the architecture of the cosmos. We have watched black holes bend space and time, listened to the whispers of ancient light, and imagined futures so distant that even the brightest stars would eventually fade into memory. Each chapter has revealed another layer of the universe. Each discovery has carried us a little farther from the familiar shores of everyday life. And yet, standing here at the end of our voyage, perhaps the greatest realization is that there is no true ending. The universe never simply concludes, it transforms. Again and again. Every ending quietly becomes the beginning of something else. This pattern is written everywhere we look. A star exhausts the nuclear fuel in its core. Its light, which may have shone steadily for billions of years, finally begins to fade. At first glance, this seems like the end of its story. Yet that same star returns its material to space through gentle stellar winds or magnificent explosions. The carbon inside distant planets, the oxygen carried through future atmospheres, the iron hidden within mountains, the calcium inside living bones. All were once forged deep within stars that no longer exist. Death becomes creation. An ending becomes inheritance. The universe wastes nothing. The atoms inside your body have already lived astonishing lives. Some were born during the first few minutes after the Big Bang. Others were forged inside massive stars that ended their lives billions of years before our own sun formed. Those atoms traveled through interstellar space, became part of new clouds, assembled into new worlds, and eventually became part of every breath you take today. Long after we are gone, those same atoms will continue their journey. Matter changes form. Its story continues. Even black holes, often imagined as eternal prisons, may not remain forever. Stephen Hawking showed that quantum effects allow black holes to emit an incredibly faint glow, now known as Hawking radiation. The process is unimaginably slow. A black hole with the mass of our Sun would survive for around 10 to the power of 67 years. The supermassive black holes anchoring giant galaxies could endure for more than 10 to the power of 100 years. Numbers so enormous that ordinary language struggles to describe them. Yet even they are not forever. Eventually, after ages beyond comprehension, they too slowly evaporate. The darkest objects in the universe may ultimately dissolve into the quiet sea of empty space. What remains afterward, no one truly knows. Perhaps only sparse particles drifting through an ever-expanding cosmos. Perhaps quantum fluctuations endlessly appearing and disappearing. Perhaps entirely new physics waiting beyond our current understanding. The farther we project the future, the less certain our predictions become. Not because science has failed, but because every answer eventually reaches the horizon of available evidence. And beyond that horizon, imagination begins. This has always been the rhythm of discovery. When Isaac Newton explained gravity, it seemed as though one of nature's greatest mysteries had finally been solved. Centuries later, Albert Einstein revealed that gravity itself was not a force in the traditional sense, but the curvature of space-time. Then quantum mechanics suggested that space-time might itself emerge from something even deeper. Each explanation became part of a larger picture. Not wrong, simply incomplete. Science rarely erases yesterday's knowledge. Instead, it gently places it inside a broader understanding. The universe rewards humility. Every generation believes it stands close to the final answer. Every generation eventually discovers another question waiting patiently beyond it. Perhaps this endless unfolding is not a weakness of science. Perhaps it is the very reason science remains alive. A mystery completely solved eventually becomes history. A mystery partially understood becomes an invitation. Curiosity survives because certainty never fully arrives. There is something deeply comforting about this. Many people imagine uncertainty as frightening, yet uncertainty is also possibility. If every secret had already been uncovered, there would be no new horizons, no unexpected discoveries, no moments when reality surprises us with beauty greater than we imagined. The unknown gives the future room to exist. Even today, we understand only a small fraction of the universe. Ordinary matter, the stars, planets, gas clouds, and every visible object, accounts for only about 5% of the total cosmic energy budget. The remaining 95% appears as dark matter and dark energy, two phenomena whose true nature remains among the greatest unsolved puzzles in modern physics. It is a remarkable thought. Everything humanity has ever touched, every mountain climbed, every ocean crossed, every work of art created, every living creature that has ever existed, all belong to the smallest visible portion of reality. The greater part of the cosmos still hides behind questions. Perhaps future civilizations will answer some of them. Perhaps entirely new mysteries will replace the old ones. Perhaps certain truths will forever remain beyond observation. Yet the search itself may be the most meaningful part of the journey. After all, the night sky has always served two purposes. It tells us about the universe, and it quietly tells us something about ourselves. Across history, every civilization has looked upward. Ancient navigators used the stars to cross oceans. Farmers measured seasons by familiar constellations. Philosophers asked whether humanity occupied a special place in creation. Scientists learned that Earth circles an ordinary star within an ordinary galaxy. The answers changed, the questions evolved, but the impulse remained exactly the same: to look upward, to wonder. Perhaps that impulse is among the most extraordinary phenomena the universe has ever produced. Over nearly 14 billion years, matter gathered into stars. Stars forged heavy elements. Planets formed. Life emerged. Consciousness awakened. Eventually, tiny collections of atoms began asking where the atoms themselves had come from. The universe became capable of observing itself. In a very real sense, every curious mind is another way the cosmos explores its own existence. This thought transforms our perspective. We often imagine ourselves as insignificant because we are physically small. Compared with galaxies, we are. Compared with cosmic time, our lives are brief. Yet significance is not measured only by size. A single eye can witness an entire sunrise. A single telescope can reveal billions of galaxies. A single question can reshape humanity's understanding forever. Meaning does not depend upon scale. It depends upon awareness. Perhaps that is why the universe feels simultaneously immense and intimate. The same physical laws that govern distant quasars also shape the neurons carrying these words through your mind. The calcium in your bones was forged inside ancient stars. The oxygen you breathe has crossed countless generations of stellar evolution. The photons reaching your eyes tonight began their journey long before human civilization existed. You are not separate from the universe. You are one of its ongoing stories. And like every story, yours becomes part of something larger. As this peaceful voyage comes gently to its close, imagine stepping outside beneath a quiet night sky. Perhaps the stars are hidden behind clouds. Perhaps city lights soften the darkness. Or perhaps countless points of light stretch from horizon to horizon. Regardless of what your eyes can see, the universe remains there. Patient, ancient, still expanding, still creating, still changing. Still holding mysteries that no mind has yet imagined. Somewhere, stars are being born. Elsewhere, galaxies continue their graceful dance. Black holes quietly shape invisible landscapes of space-time. Light older than humanity continues crossing the cosmos. The universe has not finished its story. It never truly will, because every ending becomes another beginning. Every discovery opens another door. Every horizon reveals another beyond it. And perhaps that is the most beautiful lesson the cosmos has to offer. Not that one day we will know everything, but that wonder itself has no final destination. It simply continues, patiently, endlessly, like the universe itself. So tonight, as you close your eyes, remember that while your day may be ending, the cosmos continues its silent journey. Stars will keep shining, galaxies will keep drifting. Time will keep unfolding its vast and gentle tapestry. And somewhere in that immeasurable darkness, another mystery is already waiting for the next curious mind. Thank you for spending this peaceful journey through cosmic time with us. If these quiet stories help you relax, wonder, or simply drift beneath the stars, don't forget to subscribe. Until our next voyage, sleep well, and may the universe keep whispering its mysteries through your dreams.